Hello champions, this is your Premila Ma'am and today we are going to deal with the second part of PUC, part of second PUC, and especially today we are going to deal with some important, exciting and superb sessions. So yes, I hope my audio video is all clear. Yes guys, let me know in the comment section if my audio and video is all clear. Yes or no? Yes or no? Hi Suma. Hi Aishu. Good evening, my dear. Is my voice clear, dear? Is my voice clear? Is my voice clear? Yes, all clear? Hi Tanuja, welcome on board. Wonderful, guys. Yes, Abis. So today in our class we are going to complete our coordination compounds along with all the organic chapter which is there in second PUC. Alright, so without wasting any time, let's get started. And trust me, this session is super duper important to you because the most threatened chapters are all right here. It is completely wiped here. And once you look into this video, for sure you will get a very good idea on where to look into the questions and where not. Alright? Yes. Hi Mega. Hi Rajini. Hi Tanuja. Welcome. Hi Ganavi. Welcome on board everyone. Alright. So if you talk about coordination compounds, you can easily get 2 to 5 questions from this chapter. Trust me, every year they ask questions. Somewhere around 2 to 5 questions come from this chapter. And why coordination compounds? If you see colors in your life, the colorful things which fills your life is all made up of these coordination compounds. Yes, my dear, if you look into a leaf, the leaf has green color because of magnesium complex in it. If you look into silver jewelry, it is so shiny just because of not just silver but silver complex in it. If you even take your blood, the blood is so bright red because it has iron carbonyl complex in it. So whichever thing you see in your life, the one which is so dark in color, the one which is so bright in color, everything has coordination compounds. Yes, hi everyone. Hi Percy, Chandana, Tanuja. Very good. So yes, whatever you see in your life, the one which is shiny, the one which is brighter, it has this coordination complex. But before going on to coordination complex, I would like to tell you one thing, that if you guys have not subscribed to the channel, please make sure that you subscribe to it and hit the like button, smash the subscribe button like anything before, so that you will get more and more videos from our end just like the same. Alright? For sure, Rajini, you have an extremely good trick. You have some extremely good tricks for naming reactions, for concepts and all. I'll let you know without fail. Alright? Yes. So, what you have to understand at first is, your coordination complex is made up of two salts. Yes, okay ma'am, we know it is made up of two salts. But how come I get the product as a coordination compound? Always remember, whenever you add two salts in its aqueous state and heat it, you get crystal of addition salts. Addition salts in the sense, salt 1 plus salt 2 together is called as addition salt. This addition salt is of two types. One is double salt and the other one is complex salt. And how do you differentiate double salt and complex salt? If you put your double salt in water, this double salt will give you all the possible ions which it bears. Just in case, here you have K plus, you have Al plus, and you have SO plus. As you can see, all the elements which is present there is being converted into ions. Yes, For sure, Percy, you can look into it. It is really much helpful, Kana. If you look into coordination complex, you take this coordination complex guy and put it in water. You get some ions along with a complex nature which will not dissolve, disintegrate in water. If you have that kind of a complex in hand in your salt, then that is called as coordination complex or coordination complex. Right. Okay, ma'am. Now I understand what is coordination compound because it has some amount of complex, the thing which is present inside the square bracket. Alright. But as I can see in most of the coordination compounds, nearly 99% of coordination compounds, it has a D block element as the central metal atom in between. I'll let you know what central metal atom is. Don't you worry, don't you worry. But the reason to have a D block element in your coordination compound is A, it is smaller in size. B, it has high nuclear charge. C, it has vacant orbitals. Hi Ritu. Hi Kitana. And D, it can accept lone pair of electron. Aha. Yes. Very good. Moving further, why do you need a D block element? Because my dear, you guys know that D block element, even being a metal, okay, D block metals, even being a metal, they are in need of electron in order to fulfill their octet structure, the outermost structure, right? So in order to satisfy itself, it gets electrons from the ligands, or ligands, even though they are electronegative in nature, ligands look at metal, they say, oh Pavam, this is Pavam, and the ligands give these electrons to our metal, thereby forming a coordinate bond. Since a coordinate bond is formed here, that is why the complex is called as coordination compounds. Is that clear? Is that clear? Yes. So Aishu, once we started our session, I guess there is a lot of sixes and lots of fours in IPL. We will continue the session with the same force so that even in IPL we'll get very good runs. Okay? Yes. So coming back to the concept, ma'am, everything is fine. But why do you call this metal as a central metal atom? Why do you call the nearby percent as a ligand? My dear, always remember, ligand is a particle or a molecule or an atom which gives electron to your central metal atom. And why that metal is called as CMA, aka central metal atom? Because he is like the superstar of the day. Okay, whatever ligand you have, all of these ligand will pamper our metal by giving whatever electron they have, thus ensuring that the metal gets necessary electron. So since metal is centrally placed, it is called as central metal atom. Ligands, the one which gives electrons, are called as ligands. And finally, the one which is inside this bracket, both the metal and the ligand together, is called as coordination entity. Yes, it is totally called as coordination entity. Followed by the coordination sphere, which means you can see that outside bracket there is one element which is placed. If you consider that element as well and you take this whole molecule as one unit, you call it as coordination sphere. Then ma'am, what is the name of this person? What is the name of the one which is outside your ion, outside your complex? It is none other than counter ion. Remember this, it is none other than counter ion. Got it? Yes. So guys, moving forward, we will rush with the concepts right away. I want you guys to smash the like button like anything before. Yes, everyone, smash the like button. All right. So yes. So moving forward, we have to find the classification of coordination bonds on the basis of ligand and on the basis of charge. On the basis of ligand, we ensure that R. Ma'am, will you provide us notes? Obviously, Rajani, once the session is over, I'll send you the notes. Don't you worry. Okay, once the session is over, I will send you the notes. All right. Yes. Talking about the concept, on the basis of ligand, you have two types of coordination compounds. One is homoleptic and the other one is heteroleptic. What do you mean by homoleptic? If you have, if you have same ligands, or if you have just one ligand, one type of ligand in multiple counts, then yes, that is called as homoleptic compound. If not, if you have two or three types of ligands, just in case of this example, you have NH3 and chlorine, which is two types of ligands. If you have two types of ligands, then obviously that molecule is called as heteroleptic in nature. Okay, ma'am, on the basis of ligand, now I can understand what are all the names. But on the basis of charge, how can I call a complex? If the complex as a whole has positive charge, it is positive charged. If the complex as a whole is negative, then it is negatively charged. If it is neutral in nature, the counter ion is positive and the complex which is inside the bracket is negative, making it a complete neutral, then obviously it is a neutral complex. Most of the complex which you see here is neutral in nature, so note it down, note it down, note it down. All right. So any doubts, my dear? Any doubts so far? You can ask me out. You can ask me doubt. Any doubts so far? Right. So moving forward, we will look into Werner's theory. Werner's theory is very easy. It is very easy in PC. I'll just let you know the concept with 5 factors. Our friend Werner told, our central metal atom in a coordination complex has two types of valencies. One is primary valency and the other one is secondary valency. So what do you mean by primary valency? The oxidation number is called as primary valency, and secondary valency, the coordination number is called as secondary valency. Fine. Is primary valency directional? Will you talk about direction in case of oxidation number? Will you say whether the electrons move towards central metal atom, or will the electrons or the molecule has this kind of a geometry? Can you say it by oxidation number? No, you cannot tell whether the molecule is tetrahedral or square pyramidal just by looking into the oxidation number, right? Hi Gunashri, welcome on board. That is why we say our primary valency is non-directional. Whereas in case of secondary valency, it is directional. It can explain about geometry. Obviously, you guys know, right? Based on the coordination compound, the coordination number. If it is 2, the geometry is 3 trigonal planar, 4 tetrahedral, 5 trigonal bipyramidal, and 6 octahedral. So based on the secondary valency, yes, you can explain the direction, explain the geometry, explain the isomerism. That is why secondary valency, aka coordination number, is directional, whereas the other one is non-directional. Hi Saujanya, welcome on board. Moving forward, your primary valency is ionizable because you guys know you can ionize or change the oxidation number from +1 to +2, +2 to +3, or even vice versa. That is why it is ionizable. But in case of coordination valency, no, it cannot be changed, and so it is non-ionizable. Talking about primary valency, it can be mostly negative, whereas in secondary valency, it can either be negative or by neutral. And finally, if you draw the entire element out, if you draw the entire complex out, then primary valency, aka oxidation number branches, is denoted by dotted lines, and secondary is denoted by thick lines. So yes, ma'am. No worries, Aisha. You can share it with your friends, Dakana. Everyone is listening to the class, so don't you worry. You can share it with your friends, okay? Guys, share maximum, because the count is very low, Dakana. Please share maximum, All right, shall we move forward? Any doubts so far? Let me know, guys. Let me know if there is any doubts. No doubts, right? No doubts, no doubts. Yes. Wonderful, wonderful, wonderful. Moving ahead, moving ahead. You want to learn about the disadvantage of Werner's theory as well. And the defects of Werner's theory is A. Configuration or electronic configuration of metal is not known. B. It does not explain the color of complex, why this complex is green and why this complex is red. And C. It does not explain about magnetic behavior, optical behavior of the complex. And finally, it does not talk about the directional nature of bonds. Yes. So hi, I trash. So far we have just gone through one chapter, Dakana. We have still a lot more chapter to complete. So stay tuned. Stay tuned. All right, guys. So any doubts? Any doubts so far? Just one chapter is on the verge of completion. Don't you worry, I trash. Don't you worry. All right. Yes. So now we will talk about valence bond theory. You must have learned about it in your chemical bonding as well. But I'll tell you about it again. I'll tell you about it again. So valence bond theory. What do you mean by valence bond theory? In case of coordination compounds, the central metal atom or ion will provide some vacant orbitals in order to accommodate the electrons which is donated by ligands. Yes, of course, this happens. The number of vacant orbitals formed is equal to coordination number of the metal atom. The number of vacant orbital is equal to coordination number. Alright. Ma'am, valence bond theory, can you please let me know about the same in a very easy manner? See, you should always remember that your central metal atom has vacant orbitals. Here, metal is said to be electron pair acceptor. That is why its outermost shell is unpaired. Whereas ligand is said to be electron pair donor, which means it has filled orbital. So whenever ligands orbit and metals orbit combine, they get hybridized, they get combined to form hybrid orbitals or finally the products orbitals. If you have two reacting orbitals, this will give you two product orbitals. If you have three reacting orbitals, you get three product orbitals. This is how things have to be made. Is that clear? This is all about VBT. And talking about the structure, first you have to find the steric number of the molecule, right? Or in case of coordination complex, you just have to know about the coordination number. If the coordination number is 2, then the structure is linear. 3, trigonal pyramidal, trigonal planar. 4, then it is tetra or square planar. 5, it is trigonal bipyramidal. And 6, it is octahedral. I have already told about this in our chemical bonding chapter, so I'm not going deep onto the concepts. Just look into it, just revise it. All right? Yes, guys. So moving forward, what are all the disadvantages of valence bond theory? Number one, the valence bond theory says that, okay, your reactant orbitals combine to form product orbitals, but it does not talk about how pairing of electron occurs in the presence of strong or weak ligands. He also did not explain about the electronic spectra of the entire range of ligands. He did not explain about the structure properly. And finally, he cannot differentiate a strong and weak ligand. So in order to differentiate a strong and weak ligand, we came up with an idea of spectrochemical series. This spectrochemical series will ensure that it talks about how your ligand splits your central metal atoms d orbital. If the splitting is more, strength is also more, which means the ligand is said to be strong. And in order to understand, okay, in order to understand the entire trick, yes, in order to understand the entire trick, I am going to let you know some important concept, some important story. Okay, so just give me one thing. All right. So I'll give you a story. Just follow this, and yes, you will get into the entire order of your spectrochemical series. And the trick goes like this. I brought scene glass, very good, superb glass, and sweets from Om.co. So there is a website called as Om.co. What did I do? I brought some scene glass and sweets from Om.co. I was so thirsty that I went out, got my parcel from the delivery partner. I was so thirsty. So I went to the kitchen and then I saw Nancy, my sister Nancy, eating 9 canned Coca-Cola. She was drinking 9 colas at a time. So this is what I saw and I was so shocked. This is your trick. Remember this so that for sure you will. Guneshri, see, my dear champions, you guys might be stressed, you guys might be procrastinating, you guys might have a low, even low appetite in case of your exam preparation. But all I have to tell you guys is prepare. Whenever you feel low, take your book, start preparing. Whenever you feel like procrastinating, take your book, start preparing. Whenever you feel like nothing is going to happen in this world, nothing good is there for you in this world, take your book and study, because things are so simple, my dear. If you learn, you will get your marks. If you learn, you will get your marks. And yes, I know, my dear champions, you guys are going to rock KCET, rock NEET, rock VIT, or whatever entrance exam you are preparing. So all you have to do is stay consistent and work with the flow. Right? So don't you worry, my dear champions. All you have to do is steady, practice a lot of questions, and trust me, the day when you go to your KCET exam, when you look into the questions which is given to you, you will have that smirky smile saying that, yes, this question paper is nothing compared to what I have in my brain. So that is what you want to have. Got it? Yes. So yes. So talking about the trick, you bought some cine glass and sweets, superb glass and sweets from Om.co. You went out, you bought it, you came back, so you're super thirsty. So in order to quench your thirst, you went to kitchen. You saw Nancy eating 9 canned cola, and the trick goes like this: I is for I minus iodine, brought is for bromine, scene is for SCN minus, glass is for chlorine, gla, same phonics, right? So glass is for chlorine, sweet is for S minus 2, from is for fluorine minus, Om is for OH minus, and co is for C2O4. Water, obviously H2O. Then Nancy, NCS minus. Yes, Nancy, NCS minus. 8, which is eta. 9, you have two ligands. One is N is for NH3 and Ne. If you invert it, it is En. Canned is for Cn minus, and finally cola is for carbonyl group. Got it? Yes. Superb, guys. So smash the like button if you really support for RCB. Okay, so I can see a lot of RCB fans. Smash the like button if you really love your RCB group. Okay, yes. So coming back to the next concept, next concept, which is crystal field theory. See, crystal field theory is completely different, my dear. Crystal field theory is completely different. All you have to understand in crystal field theory is, right? In crystal field theory, our owner of this crystal field theory told that the molecule, the complex which is formed, is actually not coordinate, it is actually ionic. The metal and ligand forms a bond. This is purely ionic, making sure that metal is positively charged and ligand is negatively charged. Metal is point charge, ligand is also a point charge. Then already we know we used to take d orbital or d block elements into consideration for metals. If you take a d block element, obviously it is going to have its outermost shell as d block. And yes, all 5 d orbitals of the metal atom is in first before connecting with ligand. It is of equal energy. So dxy, dyz, dZx, dx square minus y square, dz square. They're all in the same energy. Got it? Right. Then, once ligands come and cover the central metal atom, they get bonded with the central metal atom in a symmetrical model. The central metal atom, on gaining the electrons, increases its energy, right? And finally, as I told before, initially the energy was same. That is why all the d orbitals are in same energy. But once ligand comes, it is like how you must have seen in some movies. Like you must have seen like few besties then and there in your schools or college. But once they complete school, once they complete college, the entire group dissolves itself. Some used to have contact, some does not have any contact, right? In that way, just like in that way, you are equally shared all 5 d orbitals on the presence of ligand, or once ligand comes into place, goes as either high or low energy, right? Yes. Got it, guys. Hi Somshekara, good evening Kana. Yes. Coming back to the concept. Ma'am, which one forms lower energy and which one forms higher energy? As you can see, dxy, dyz, dxz, they all form lower energy. Whereas, if you talk about dx square and minus y square, dz square, they form higher energy. Why, ma'am? Why so? See, you guys know always the ligand approaches the central metal atom through their axis, right? Through either x-axis or y-axis or z-axis. Once they approach through the axis, since there is no electron in the axis in case of dxy, dyz, dzx, the ligand will move forward and ensure that the energy is lowered with respect to these three. But in case of dx square minus y square and dz square, you can see that the lobes are actually there, present in the axis, which means ligands cannot approach, they will be completely stopped by means of electrons, because ligand is also negatively charged, electron is also negatively charged, and yes, due to high repulsion, your dx square minus y square and dz square is absolutely going to be with high energy. Got it? Yes, Shetty. Wonderful, Kana. We are waiting for the same. Super, Aishu. Superb, guys. So happy to see. Yes. So this is how things work out with crystal field theory. You have to remember the structure, but don't you worry. I'll let you know a trick once we go into the questions. Okay. So don't you worry about the same. Alright. So now, finally, we will talk about the magnetic properties of coordination compounds. See, whatever the element is, I just want you guys to remember one thing. If you have one unpaired electron, look into the unpaired electron which is present. If you have one unpaired electron, then your mu value, magnetic moments value, is going to be 1.8. If it is 2 unpaired electrons, it is going to be 2.8 or 2.9. If it is 3 unpaired electrons, it is going to be 3.9. 4 unpaired electrons, it is going to be 4.9. So on and so forth. So you just have to understand or find the total number of unpaired electron, and voila, you will find the magnetic moment. Got it? Yes. Wonderful, guys. Moving forward, we will talk about the isomeric structures of coordination compounds. As you can see, we have two major isomeric branches. One is stereoisomerism and the other one is structural isomerism. In stereoisomerism, you have 2 types, and in structural isomerism, you have 4 types. Stereoisomerism is converted into geometrical and optical isomerism. Structural isomerism is converted into 4 types, which is ionization, hydrate or solving, linkage, and finally coordination isomerism. We will look into it one by one. Right? So talking about geometrical isomerism. Geometrical isomerism talks about the arrangement of ligands around the central metal atom. How your ligands are arranged in such a way that the entire structure remains the same. You just have to ensure that the branches are said to be distributed. Got it? Got it? You also have cis and trans isomerism in case of coordination compounds as well. I'll let you know the structure one by one. So as you can see, always remember, if the atoms are same, mean both the ends, then obviously it is going to be cis. If the atom is different, it is going to be in diagonal manner, it is going to be trans isomerism. And talking about the geometrical isomerism, you guys have to remember these structures like Ma2B4, then Ma5B, then Ma4B2. These are all the structures. Yes, Bellustic, I completed crystal field theory, Dakana. How long will the session go? You have just some more sessions time left. So just now we have completed one chapter. So one chapter you might be completing within 40-45 minutes. You have 5 to 6 more chapters left. So you can calculate the time. Okay. Yes. So Bellustic, I have completed CFT Dakana. Now I am talking about isomerism. Alright. So today I am going to complete the entire organic chemistry and coordination compounds from PUC. Got it, got it, got it? Yes, 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 guys. So now the match is over. Please focus on to the session. Focus on to the session. And yes, talking about the session, we move on with the next part, which is optical isomerism. You guys know what is optical isomerism? When you pass a plain polarized light alongside your element. Like say for example, this is my element. You pass a plain polarized light this way and the plain polarized light get inverted either clockwise or anti-clockwise. Then that is called as optically active element. Right? So in case of optically active element, what you have to understand is if you are, the rotation is clockwise, then it is dextro, positive in nature. If it is anti-clockwise, then it is levo, negative in nature. Got it? Got it? Got it? Yes. Other than this, in optical isomerism, there is not much of a thing which you have to remember. If you have an equimolar mixture of D form and L form, which is dextro and levo, clockwise rotation and anti-clockwise rotation, then it is called as racemic mixture, aka enantiomers. Since the rotations are said to be in same, both the ends, then they are said to have, or then they are said to be optically inactive. Hi SA, welcome, welcome, welcome on board. Shetty, once we complete the concept, we will look into the question, guys. So don't you worry, don't you worry. Alright. Also remember tetrahedral complexes with MAB square will always exhibit optical isomerism. This is a very, very important point. Note it down, structure having M, A, B twice will always have optical isomerism. Got it? Yes. Talking about enantiomers are non-superimposable. Okay, they are non-superimposable mirror image, stating to the fact that if you have, say for example, I have some connector wires here. I'll show you to you as an example. Okay, so I have some connector elements here, right? So as you can see, if I keep one this way and if I keep another one this way, then these two are said to be non-superimposable mirror images. Yes, non-superimposable mirror images, stating to the fact that it cannot be superimposed. Even if you keep it this way, then obviously you are going to identify that something is behind this one. Right? So that is called as non-superimposable. Got it? Yes. So yes, guys, we have completed enantiomers as well. So the next thing is structural isomerism. Structural isomerism is quite easy. Trust me, you can easily find the answers. And the very first structural isomerism is absolutely ionization isomerism. So what do you mean by ionization isomerism? The one which is outside the bracket is counter ion, and the one which is inside is called as your ligand. If your ligand and counter ion just interchanges to form two or more structures, then obviously that structure or that isomerism is called as ionization isomerism. Yes, and talking about hydrate or solvate isomerism, if at all you have some amount of water or some amount of solvent in your molecule, and because of that water molecule present there, if the color, if the nature, and if the characteristics differ, then that is called as hydrate or solvate isomerism. Example, as you can see, CrH2O6 Cl3 is violet in color, whereas CrH2O5 Cl2H2O is said to be gray in color. So remember this, if you alternate the water molecule, it is going to give you hydrate or solvate isomerism. For sure, Diksha. For sure, Rakana. Is there any doubts with ionization isomerism and solvate isomerism? If you have so, let me know. Hi, Slayer Slot. Welcome on board. If you have any doubts with these two, let me know. I'll repeat it once again. Yes. And also, guys, please smash the like button and subscribe to the channel. Come on, guys. Do you have any doubt? Doubt. Any doubts? No. Wonderful. Moving forward, we have linkage isomerism and coordination isomerism. Linkage isomerism is mainly caused due to ambidentate ligand. You guys know what is ambidentate ligand, right? Say for example, if you take NO2, there are some stances where nitrogen connects with the metal and some stances where oxygen connects with the metal. Similarly, in case of CN, there are some stances where carbon connects with the metal and there are some stances where nitrogen connects with the metal. So in this case, if you have two structures formed by means of ambidentate ligand, the ligand's naturality, then obviously, due to the presence of ambidentate ligand, they are all called as, since the linkage is differed, but the ligand is same, the isomerism is called as linkage isomerism. Finally, talking about coordination isomerism. In this case, you have two parts, two brackets or two coordination spheres. One is cationic part and the other one is anionic part. If the molecule, right, if the element which is present inside your anionic and cationic part differs or it gets altered, then it is called as coordination isomerism. Don't you worry, I'll show you some questions about coordination isomerism. Once you look into the question, you will get an idea. Alright, so the very first question of the day, let me know the answer for the same, guys. Let me know the answer for the same. Hi Malika Arjun, welcome. Rajani, once the session is over, I'll pin these notes in the comment section so that you can look into the same. Yes. So let me know your answers in the comment section below. Okay. Yes. A lot of bees. Yes, very good, my dear. So here you can see only the ligands are interchanged, right? The ligands are, even you can say that only the central metal atom is interchanged. Copper goes here, platinum comes here. If the central metal atom or just the ligand is interchanged, if interchanging of ligands or central metal atom occurs, then that is called as coordination isomerism. So now I hope you got an idea of what coordination isomerism is. Alright, I'll give you another question. Let me know the color of this compound. Yes, guys, let me know the color of this compound. Yes. There is a lot of confusion, I guess. There is a lot of confusion. Come on, guys. Come on, come on, come on. Please answer. Please answer. Okay, okay. So the correct answer for this question is absolutely purple. Absolutely purple. The reason why I asked you is you have to remember cobalt chloride only. You have to remember cobalt chloride complex and its color. It has been asked before in KCET. Remember it, remember it. All right. It is purple in color. It is purple in color. Moving further, I'll give you another question. I'll give you another question. Please look into this question and let me know your answers. If platinum and PtCl4HCl has a secondary valency of 6, how many moles of AgCl will participate with excess AgNO3? Let me know your answers. Likita, which question, Kanna? Which question are you asking about? Okay. Yes, yes, yes. So the correct answer for this question is 0. Because, see, just look into the question, okay? Just look into the question. PtCl has a secondary valency of 6, right? PtCl has a secondary valency of 6. Then, how many moles of AgCl will of compound will precipitate with excess AgNO3? The question is how many precipitate will you form, right? But you can see that the secondary valency coordination number is 6, which means this platinum needs 6 chlorine to be connected with it. So the platinum is connected with 1, 2, 3, 4, 5 and 6 chlorines. If it is connected with 6 chlorines and you just have 6 chlorines in total, will it going to give any precipitate of AgCl? No, right? No, obviously no. And so the answer is option A. Got it? Yes, very good, very good, very good, guys. So I'll give you one last question of the day. Let me know your answers in the comment section. Werner postulated that octahedral, tetrahedral, and square planar geometrical shapes are more common in coordination compounds of which one? Yes, yes, yes. Come on, guys, come on. I will zoom in the question. Let me know the answers in the comment section. Lag? Is there any lag, Ajay? Please let me know. Please let me know. If there is any lag, let me know, let me know, let me know. So, ballistic, the question goes like this, Dakana. Okay, the question goes like this. Amongst these, the common central metal atom is, or the one central metal atom with octahedral, tetrahedral, and square planar structure is. Very good. It is going to be transition metals. Option D is the absolute perfect right answer. With this, we are completing our coordination compounds. Next, we will look into the very easy PC chapter of the day, which is alcohols, phenols, and ethers. Trust me, this chapter is super duper easy. You don't have to break your head like anything. All you have to do is just learn it a little bit. It is going to be super easy. Just learn it a little bit and voila, you will be masters in this chapter. So talking about the chapter, you have a very big syllabus here. I'm not going to talk about the syllabus, but yes, talking about this chapter, you can easily expect 2 to 4 questions. Predominantly, you get somewhere around 2 questions every year. Sometimes you get 4. So 2 to 4 questions comes pakka from this chapter. Okay, are you guys ready to get that mark? Velocity, after alcohol phenol, after aldehyde ketones, we will go with haloalkanes and haloarenes rakana. Yes, yes, yes. Okay, so talking about the classification of alcohol based on the OH group present or number of OH present, we classify our alcohols as monohydrate, dihydrate, trihydrate, and polyhydrate. Monohydrate means mono means one, hydrate means OH group, which means there is only one OH. Dihydrate, two OH groups, which means there are two OH just in how you see ethylene glycol. Then trihydrate, in the same molecule you have three OH. What is this name? What is the name of this molecule? It is called as, hi Preetham, welcome on board. So it is called as glycerol or glycerin. And polyhydrate, which means you have a lot of OH. Example, sorbitol. In sorbitol, you have 6 OH groups connected. So this sorbitol is kind of important. Note it down, note it down. Alright? Yes. Talking about the hybridization, I have already told about this many a times. If your carbon has single bond, it is sp3 hybridized. If a carbon has double bond, it is sp2 hybridized. And if your carbon is triple bond, it is sp hybridized. Yes, yes, yes. Got it. Next, what does mean by alcohol? Why did the name come? See, you have an alkyl and hydroxyl group connected together. Alkyl groups form alk of your name, whereas hydroxyl group forms OH or OL of the name. That is why your name combined, alkyl, hydroxyl combines to form a term called as alcohol. So what is meant by your alcohol? It means alkyl and hydroxyl. Alkyl group and hydroxyl group together forming alcohol. Is that clear? Is that clear? Okay. So we will talk about compounds containing sp3OH bond. Always remember, if your carbon is sp3 hybridized, then you might have primary, secondary, and tertiary structures. What is meant by primary structure? Whenever your OH is attached to a carbon, that carbon is called as primary carbon. If the primary carbon is, alpha carbon, that carbon, if it is attached directly to another carbon, just one carbon, then that count undergoes or that count indicate that it is 1 degree. And yes, this structure is primary. Yes, then talking about 2-degree structure, always remember if your alpha carbon is connected with 2 carbon groups, it is 2-degree or secondary. And finally, if your alpha group connects with 3 carbon, just in this case, 1, 2, 3 carbon, then it is going to be tertiary group. So remember this, it is going to be super duper easy. Alpha carbon connected to 1 carbon, primary, 2 carbon, secondary, 3 carbon, it is tertiary. Yes, yes. So Tarun, I'll let you know the question Karna. Okay? Yes. So Darshan, I'm not in some kind of acting group or so, Karna, to overreact. If you feel so, you can quit. You can quit anytime. Right. Talking about allelic and vinylic structure. What do you mean by allelic structure and what do you mean by vinylic structure? Always remember, the alpha carbon is the one which is attached to the functional group. If your alpha carbon is sp3 hybridized, then it is allelic structure. Then if the alpha carbon is sp2 hybridized, then it is vinylic structure. Okay, so if the alpha carbon is sp3 hybridized, it is allelic structure. If the alpha carbon is sp2 hybridized, it is vinylic structure. But always remember, in case of allelic structure, your alpha carbon is sp3, but the nearby carbon 2 alpha carbon is said to be sp2. Got it? Got it? Yes. Yes, Ashish. So Ashish, I came in the middle, Rakana. I came in the middle from your KCET preparations and all. But yes, you can watch a lot of videos here in this channel about me, from me. and whichever sessions you want. If you want any session, if you have any suggestions, you can reach out to me through Instagram, and my ID is neat_Premila_chemistry. So guys, if you have any doubts, if you have to reach out to me, if you want to speak in person, I am there available in this Instagram ID. All right. Yes. So we have talked about our allylic and vinylic structure. What next? It is none other than benzylic and phenylic structure. My dear, always remember, whenever you take a benzene ring and you remove one hydrogen from it, then that structure is called as phenylic structure. You take that same benzene ring and add one methyl group onto it, then that structure is called as benzylic structure. Yes, so if you remove a hydrogen, it is phenylic. If you add a methyl group, it is benzylic. Thank you so much. Inspire, Shreyas Lord. Thank you so much, Rakana. Yes. Next, you guys have to remember the difference between the two, because in upcoming days you will be learning a lot about phenol in this chapter. So please remember this. Right. So talking about monohydric structures of alcohol, we have allylic, benzylic, alkylic structures, whereas about sp2 hybridized, we have vinylic structure. I have talked about these beforehand. Now we will move on with the preparation methodology of alcohol. Yes. Thank you everyone. Thank you so much, Rakana. Lots of love. Yes. So if you talk about the preparation of methodology, whenever you take an alkene and you either acid catalyze them, you take them under oxymercuration, demercuration. The word might be very big, but it is super simple, guys. I'll let you know. Oxymercuration means addition of mercury. Demercury means removal of mercury. And so if you add mercury and remove mercury from alkene, you will get an alcohol. Right? Just know this. You don't have to know the entire reaction or so. It is not going to help. So talking about acid catalyzed hydration. What does mean by acid catalyzed hydration? The name in itself let you know the reason. Acid catalyzed. You are going to use your acid as a catalyst to enhance or speed up the reaction, and you are going to add a water onto it. You are going to hydrate the molecule, and thus you get your alcohol. So what happens here is, yes, guys. So coming back to the concept, what happens here is your H2O molecule becomes H plus and OH minus. You also have a double bond here. Break that double bond like anything, how your, in Naruto does. So you just have to break this double bond and you have to add your hydrogen and your OH once again. Since you just have 2 carbon and same count of hydrogens here, you don't have to go for Markovnikov's or anti-Markovnikov's rule in case of ethylene. But in case of 3 carbons, 4 carbons, 5 carbon structure, you have to make sure that you follow Markovnikov's or anti-Markovnikov's rule. So what does mean by Markovnikov's rule? First, always remember, if you have to break a double bond, you should either consider Markovnikov's or anti-Markovnikov's rule. So where to use Markovnikov, where to use anti-Markovnikov. Always remember, if you are going to break a bond and add something onto it, then if it is done in the presence of a peroxide, remember, if it is done in the presence of a peroxide, then you follow anti-Markovnikov's rule. But if it is not done in the presence of peroxide, if you do not have a peroxide, then you take this into Markovnikov's rule. Got it? So what is Markovnikov's rule? I'll tell you a simple concept. Like it might hear or it might sound like a communist kind of a word, but the concept goes like this. In case of Markovnikov's rule, the rich gets richer. The one who has lot of hydrogen will get an extra hydrogen. Say in this molecule, If I break this bond with the help of HBr, then the hydrogen in HBr is going to be placed in the region where there is more hydrogen. And yes, 1, 2, 3, this carbon has more hydrogen, and so the hydrogen is attached here, whereas the bromine gets attached with the area where there is less hydrogen. So Markovnikov's rule, rich gets richer. In case of anti-Markovnikov's rule, all you have to remember is, in case of anti-Markovnikov's rule, the poor gets richer. Okay, so I'm taking the same molecule, which is C double bond C, CH3. Here you have H2, sorry, H, and here you have H. Right? So what happens here? If I use HBr and a peroxide, say for example, if you use H2O2, in presence of peroxide, I will go with anti-Markovnikov's rule. And what does anti-Markovnikov's rule say? Poor gets richer, which means when you break this bond, see where there is lesser hydrogen. You have less hydrogen with this carbon, and so in HBr, hydrogen goes here, bromine goes here, and the final product will be CH2, Br, CH2, CH3. Got my point? Got my point? Yes. Very good guys. Diksha, any doubts, Diksha? Thank you Rajani. Thank you so much, Rakana. Thank you so much, Ashish. Yes. So I hope the concept is clear. Is there any doubt with this part? Is there any doubts with this part? Hi Aishu, welcome. Any doubts? Shall we move on with the next part? Shall we? Yes. Okay. So moving further, we are going to deal with the second method of preparation, which is before that we will understand the steps involved in the process of conversion alkene to alcohol. The first process is electrophilic attack of H3O plus. The second process is nucleophilic attack of H2O on carbocation, and final process is deprotonation of the molecule. So what is mean by electrophilic? Electron loving particle attacks the negative end, which is electrophilic. Nucleophilic, nucleus or positive charge loving molecule attacks the positive charge loving molecule, attack the positive end, which is nucleophilic attack. And yes, when electrophilic followed by nucleophilic followed by deprotonation occurs, your entire process is done and dusted. Got it? Yes. Very good, guys. Moving to the next part, which is hydroboration. Guys, remember, hydroboration is very much important. You also had 2 years of question papers bearing this concept. So remember, hydroboration is very much important. So what happens in hydroboration? You take your carbon, double bond carbon, which is alkene structure. You make it react with hydroborate, which is hydrogen and boron mixture, along with the peroxide. Peroxide comes, double bond is going to break, which means you are going to follow anti-Markovnikov's rule. So what happens in anti-Markovnikov's rule? The area where there is less hydrogen, poor gets richer. Where there is less hydrogen, the hydrogen will go and connect, whereas where there is more hydrogen, your another molecule, boron, will go and connect. So this is how the entire process goes on. Remember, you just have to ensure that you guys are clear with the concept of Markovnikov's and anti-Markovnikov's rule. Right? Okay, so moving further, we will move on with the next concept, and that is by reduction of aldehydes and ketones. Always remember, whenever you reduce aldehyde and ketone, you can use any strong reducing agent like nickel, platinum, palladium, hydrogen, or lithium aluminum hydride, or even NaBH4. Any strong oxidizing agent, reducing agent, you will finally get a primary alcohol. Right? Primary alcohol. But in case of ketone, you get both primary and secondary alcohol. Similarly, you have to understand this. Your NaBH4 acts as a strong reducing agent only for aldehyde and ketone, not for carboxylic acid and ester. And so for carboxylic acid and ester, you get lithium aluminum hydride. So there might be some kind of a question, right? So you might have your carboxylic acid here, you might have your NaBH4 here as a reagent, and they might ask you the product. So the answer is no product formed, because it will not reduce the molecule. Yes, for sure, Karnataka, second PUC Karnataka, for sure you will get Kana. It is very easy, but trust me, you have to practice some questions as well. Most expected questions are already posted in Vedantu Karnataka. Please look into it. It will be really helpful. All right? Yes. Next, talking about Grignard reagent. What is Grignard reagent? This is called as Grignard reagent. So always remember, it is an organometallic compound where organo stands for alkyl group, metallic stands for magnesium group, and the halide is also present. Right. So talking about this organometallic molecule, always remember, whenever your Grignard reagent reacts with formaldehyde, it forms 1 degree alcohol, which is primary alcohol. If it reacts with any other aldehyde, say for example acetaldehyde, propanaldehyde, any form of aldehyde other than formaldehyde, it will give you 2 degree alcohol, and finally if you make it react with a ketone, it will give you 3 degree alcohol. Yes, sure Ajay, we will solve a lot of questions. So always remember, poor carbonyls are aldehyde and ketone, impure carbonyls are carboxylic acid, ester, and acid and hydride. Just you have to understand the concept. Okay, moving forward, we will understand the preparation or the process of preparing phenol. Right? First, in order to prepare phenol, you take a haloarene, and on reacting this haloarene with an aqueous base solution at high temperature and high pressure and hydrating them, you get phenol. Guys, always remember, this process is also called as Dow's process. Dow's process was asked like 2 to 3 times in your KCET exam if you see all of the question papers. So yes, it is very important. Right? Yes. So Slayer slot, what happened, Nakana? What happened? So always remember, in case of nucleophilic aromatic substitution, in case of substitutions wherein which you have aromatic components in line, you should remember and you should always remember that it is very difficult to do it in the general conditions with normal temperature and normal pressure. That is why you ensure that you make sure that your temperature is high, pressure is also high, so that the process becomes easier and feasible. Got it? Yes, guys. So we will move on with the benzene sulfonic acid reaction. Whenever you take your benzene sulfonic acid, react it with any alkaline group at high temperature and pressure and hydrate it, you get your phenol. Then with diazonium salt, all you have to do is take some hot water, pour it in your diazonium salt, mix it, kalak, and you will get your phenol. Alright? Yes. So, yes, guys. Moving on with the cumin. Remember this. In case of cumin is none other than your benzene structure connected with 3 carbon filtered group, which is propyl structure, or this is also called as isopropyl benzene. So whenever you react your isopropyl benzene along with oxygen, you ensure that your benzene ring gets the OH, whereas your propyl structure gets your oxygen. One oxygen is equally shared among benzene ring and your propyl ring, thus ensuring that you get your phenol and your propanol. Yes. Is that clear, guys? So wonderful. Next, we will move on with the physical properties. In general, you have to remember that your boiling point is directly proportional to the van der Waals force, molar mass, surface area, and inversely proportional to the number of branching. Remember this, my dear. So boiling point is directly proportional to van der Waals, mole of mass, surface area, but it is inversely proportional to branching. If you have a lot of branching, then it is easier to cut the branch by means of giving some temperature. That is why boiling pressure is like the boiling point is inversely proportional to number of branching. Right. So I'll give you a question. I have three molecules: CH3OH, CH3, CH2OH, CH3, CH2, CH2OH. I call them as A, B, and C. Let me know which one's boiling point is maximum. Let me know which one's boiling point is maximum. Let me know, guys. Let me know your answers in the comment section below. Okay, Slayer Slot. Thank you, my dear. Very good, Ganavi. It is also proportional to unpaired electrons. Yes, you can say that as well. Hi, Dr. Priya. Hi, Soumya. Welcome on board. So we have a lot of answers here. And you guys are absolutely right. The correct answer for this question is absolutely option C. Because as you can see, the molar mass is large for the third molecule since it has 3 carbon. And yes, whenever molar mass is large, boiling point is also large. And so option C is the absolute correct answer. Very good, my dear. Okay, so I will give you another concept which you have to remember. Always remember, in case of alcohol, ether, and alkene, alcohol will have a greater or larger boiling point than that of ether and alkane. Why? Because in alcohol you have both van der Waals forces as well as intermolecular hydrogen bonding. But in case of ether, you just have van der Waals force and dipole moment. Hi, Crazy XYZ. Welcome on board. Yes. So that is why. So Dr. Priya, I'll be there in the Tamil channel as well, Kana. Don't you worry. Our sessions will be there for sure in Vedantu NEET Tamil. So don't you worry, my dear. Yes. So talking about ether, since ether just has van der Waals force and dipole interaction, you guys know hydrogen bond is very much stronger than dipole interaction. That is why alcohol stays first, then ether, and finally alkane. Right? Talking about the chemical reaction, whenever your alcohol reacts with a metal, it will form a metal alkoxide. Say for example, if reacts with sodium, it forms sodium alkoxide. If it reacts with aluminium, it will form aluminium trialkoxide. Always remember, the name should be of this order, which is metal. Number of metallic charges form. Say for example, aluminium it is +3, iron it is +2 or +3, sodium it is +1, somewhat like that. And your name, if it reacts with alcohol, it is alkoxide. If it reacts with phenol, it is phenoxide. Also, one important factor which I have to address here is, always remember, amongst alcohol and phenol is said to be most acidic because of the resonance structure. So if you talk about the acidic strength in an overall manner, comparing all the functional groups, then you say carboxylic acid stands first, followed by sulfonic acid, then triple bonded molecule, just like acetylene, then your phenol, then double bonded molecule, then alcohol, and finally amine structure. Also remember one thing, that your water, I'll show it to you. Where is it? Okay. So your water is pretty much acidic than alcohol. Even if water is acidic, then absolutely alcohol is basic in nature. Is that clear? But is all alcohol basic in nature? This is the question for the day. Is all alcohol basic in nature? Let me know, my dear, and smash the like button like anything before. Smash it out. Let me know in the comment section, guys. Let me know in the comment section. Are all the alcohols basic in nature? Are all the alcohols basic in nature? Hi, Drakshini. Welcome, welcome on board. Yes, yes, yes. Hi, Crazy XYZ. Hi, Preetu. Yes, tell me the answer at first. Are all alcohols acidic in nature? Sorry, basic in nature. This is your statement. All alcohols are weaker or weakly acidic than water, or not water, than phenol. Is this true or false? Is this true or false? What is an exception? What is an exception? If it is no, then what is an exception? Why so? Why so? Can you please let me know? Why so, my dear? Why so? Soumya, reading alcohol makes me intoxicated. Let me know the reason, guys. Let me know the reason. Why? Why the statement is false? Why the statement is false? Why this statement is false? Because the reason is amongst all the molecules of alcohol, methanol is said to be, or methanol is said to release ready alpha hydrogens once it dissolves in water. And whenever a particle releases hydrogen, H plus ions like anything, then obviously it is going to be strong acid. That is why I say methanol is a strong acid than phenol. Okay, so the order becomes methanol, then phenol, finally ethanol. Got it? See, all alcohols except methanol is said to be less acidic. Methanol is an only exception which you have to remember. Is that clear? Is that clear? Guys, please smash the like button and subscribe to the channel for more such videos. Alright, so if I talk about the acidic nature of the same, always remember methanol comes first, followed by phenol, then water, then 1, 2, 3 degree alcohols. Is that clear? Yes. Diksha, it is not a game, Dakana. I cannot do anything. Right. Hi, not expert in editing. Hi, Kanna. Hi, Tilak. Welcome, welcome, welcome. So, yes, when we talk about acidity of phenols, why do phenols have very good acidity? So, the reason is it just has your benzene group. Benzene group has a resonance structure. And yes, due to resonance stabilization, your phenol are said to be very much acidic in nature than most of your alcohols. Right. Talking about the effects of acidic character by substituents. Always remember, if your functional group, say alcohol or ether or whatever it is, if it has a minus I group, like electron withdrawing group, like chlorine, iodine, or even nitro group, they're all acidic in nature. They all increases the acidic character. Whereas if you have a plus A group, which is electron donating group, obviously the acidic character would reduce. Okay? Yes. Coming back to the very first question of the day. Let me know your answers. Let me know the acidic order of the following molecules from least acidic to the most acidic version. You have 7 elements here. Just let me know the acidic order of the same. Come on, guys. For those who have asked for the question, come on. Let me answer. Let me know the answer. Hi, Reena. Hi. Let me know the answer for this question, guys. Let me know the answer for this question. Hi Asmita, good evening, good evening. So look into the question and let me know the answer. Hi Snehal, welcome on board. Yes, crazy XYZ. Let's crack KCET like anything before. Hi CVK, welcome, welcome, welcome. So Navya is the first one to answer GEF. Uh-uh. The answer went. Guys, smash the like button and do subscribe the channel. Yes. So gonna be DEFGBAC. Hi, SR Fit and Health, Nutrition and Wellness Center. I'll call you SR Fit, okay? Hi, SR Fit. Yes. So the correct answer for this question is absolutely. First, it is absolutely going to be ethanol, the least one, followed by water. Then you have phenol. Then you have phenol with your CH4 in meta group. Then para, then ortho, finally methanol. So order is in this way. Always remember if the substituents are same. Then acidic character is maximum in ortho, then in para, finally in meta. Okay, ortho, para, meta. Remember it as opium. Opium. Okay, in Kerala, we used to eat a dish called as appam. Appam. Did you hear it? Have you guys heard about it? Appam. So remember that appam, you will remember this opium. Okay, opam, appam, opam, appam. Or even about Korea. Korean dramas, you must have seen that your heroine will call the hero as Oppa, right? Oppa. So remember that. Oppa, opium, your substituents are the same. Then ortho will have acidic strength maximum, then para, then finally meta. Yes! Very good, very good, very good, guys. Then, moving on with the next concept, which is the relation between reactiveness and stability. Guys, always remember whenever the charge increases, the stability decreases and the reactivity increases. That is why considering a methoxide ion and phenoxide ion, methoxide ion is less stable than that of phenoxide. Remember this, remember this. This was once asked in KCET. Methoxide is very much less stable than phenoxide ions. Yes. Okay, moving on with esterification. So what is esterification? What is exactly ester, guys? So as you can see, this is my Instagram ID, neat underscore Premila underscore chemistry. If you have any doubts, you can reach out to me to this Insta ID. Trust me, guys, I will reply for sure. Okay, so what is esterification? Whenever you mix your alcohol with carboxylic acid, you get a sweet, fruity smelling compound called as ester. If you do not have an carboxylic acid, no worries. You can either take an acid anhydride, mix it with alcohol, collect, and you get ester. Right? So remember this, ester is RCOR dash and it is fruity smelling. Got it? Yes. So coming back to the reactions, always remember whenever your alcohol reacts with Lucas reagent, you can find whether the alcohol is 1 degree, 2 degree or 3 degree. How, ma'am? And what is Lucas reagent exactly? See guys, HCl along with zinc chloride is called as your Lucas reagent. When you add it to primary alcohol now, it will not react. On heating the molecule, it will slowly react, very slowly react, and that will ensure that it is primary alcohol. If you add the same Lucas reagent to a secondary alcohol, it will react within minutes, and yes, you can say it is secondary. And finally, if you add this Lucas reagent with tertiary, as you add it now, immediately you can see some bursting out turbidity, like that soap froth now, that froth kind of a thing coming out, within seconds, which means the reaction has been done within seconds, and thus if the reaction is done within seconds, then it is tertiary alcohol. So if it is non-reactive or very slow reactive, then it is primary. If it reacts within few minutes, it is secondary, and if it reacts within seconds, it is called as tertiary. Got it? And how come you know that it reacts or not? You will see some frothy kind of a substance taking, you've been prepared that frothy kind of soap-like, frothy kind of bubble-like structure forming is called as turbidity. If you get the turbidity, then yes, reaction occurs. Okay. Yes, Kriya, you are absolutely right. Initially, when you add Lucas reagent, primary alcohol will not react. Then you have to heat it a bit so that very slowly the reaction occurs. Got it? Yes. Talking about phosphorus trihalide. If it reacts with phosphorus trihalide, then obviously it is going to be your alkyl halide and H3PO3. Remember, trihydrates will only react with trihalides. You will not make sure that a mono alcoholic group, just one monoalcoholic group reacts with your phosphorus trihalides. If you just have monohydrogen groups, you should take 3 in number. If you have trihalides groups, then obviously you should take it 1 in number. Okay, so next about oxidation, always remember 1 degree, 1 degree alcohol with a weak oxidizing agent will give aldehyde. 2 degree alcohol with a weak oxidizing agent will give you ketone. If I use a strong oxidizing agent, then obviously 1 degree will give you carboxylic acid, 2 degree will give you ketonic, and 3 degree will give you alkanes. Got it? Yes. Gagan, don't you worry, which means if you are forgetting things, which means you have to practice a lot, revise a lot of concepts once again. Re-revise. Okay, guys. So next we will talk with dehydrogenation. What is meant by dehydrogenation? You are going to remove your hydrogen, that is called as dehydrogenation. You are removing your hydrogen. From 1 degree alcohol, you can get an aldehyde, from 2 degree ketone, and 3 degree alkene structure. Remember this. Okay? Yes. So next, some people used to have doubt about turgidity and turbidity. What is turgidity and turbidity? Class duration, Likita, I am not sure, Likita, I am not sure. But I can let you know that it might extend a bit more. Hi, Adya, welcome on board. So turgidity, in the sense, it is like forming a formation of a bolt from the blue, right? So whenever you form a globule kind of a structure from your metal surface, it is called as turgidity. Whereas in case of turbidity, you can see that froth is being formed, right? Just like that soap molecules, froth is being formed, and that is called as turbidity. So just remember this. This will not be asked in question, but yes, understand what is the difference between these words, right? Who said paper leaked? Ruchita, who said paper leaked? Paper is not going to leak, and even if it gets leaked before the exam, they will change the question paper. Don't you worry. So guys, do you know how your papers are actually set? In general, how your papers are all set? You should know this, okay? You should know this. See, even for KCET, for NEET, for JEE or whatever exam, even for civil service exam, not just one paper is created at a time. You will have some 5 to 6 question papers created by various other faculties of the board. So what happens? They take all of these question paper, they shuffle it, and then they take the right question paper out. This is how each and every exam's question paper is set. So even if the question paper is, the correct question paper which you guys are hoping for gets re-released or pre-released, then obviously you will have another set of question paper ready for the day. Okay, Sihi, break. Guys, you can take break. You can take break, Dakana. You can take break, okay? Meanwhile, you can go, you can relax, you can come back. I'm here for you. All right? Yes. So, guys, coming back to the concept. Talking about electrophilic aromatic substitution, we will just complete this chapter and then we will take break for now. Electrophilic aromatic substitution, we will talk about nitration and bromination. Even if you talk about nitration and bromination, always you have to remember, if you use a dilute acid, then obviously you are going to get your nitro groups attached in the ortho and para position. Guys, like the session for more such values. Okay, Preetu, Soumya, and everyone, those who ask for ask for break. Even if you ask out, I would be so happy, my dear. Those who ask for break, just give me some time. I'll finish this chapter and give you break. Okay. Yes, talking about your nitration with concentrated HNO3. Always remember your nitro groups attached to all possible areas, which is ortho and para nitro groups. So yes, dilute means only either ortho or para. If it is concentrated, then you will have nitro each and everywhere. Just like how you have just, if you have just 10 rupees in hand, you will just buy one chocolate, right? One small chocolate. If you have some 100 or 1000 rupees in hand, then you are obviously going to be the richest person of the day and you are going to buy whatsoever chocolate you want from the chocolate factory, right? So just get this in your mind, right? Hi Likita, hi, fearless fame, hi, welcome. So guys, please, hi Meghna, hi Muttu. So please make sure that you note it down. The same goes on with bromination. In case of a non-polar solvent, well, with like CS2, CCl4, your bromine gets attached either in ortho or para position. But in case of a polar solvent like H2O, your bromine will get attached in both ortho and para position. Got it? Yes, Kriya. Major product ortho. It is not ortho or para. It is ortho and para. Okay. Yes. Right. So next we will talk about Kolb's reagent reaction. This is very important. All you have to remember is first, make your phenol react with NaOH so that hydrogen along with OH is removed as water. This Na connects here so that you will get a salt or a sodium phenoxide salt. This sodium phenoxide salt on reaction with CO2 and H+. Since it is Kolb's, K-O-C-O, co, just understand that way with phonetics. If you react it with carbon dioxide, then obviously you are going to get salicylic acid. Remember, my dear, this is actually an electrophilic addition reaction. This was actually asked, and the electrophile here is carbon dioxide. Is that clear? Hi, Likita. Welcome. Right. Talking about the application of your salicylic acid, always remember it is used to prepare aspirin in the presence of acetic anhydride. So whenever your acetic anhydride reacts with salicylic acid, it gives aspirin. You guys know about aspirin because it has many medicinal benefits. Right. Next, about Reimer-Tamer reaction. What is Reimer-Tamer reaction? It is a very easy reaction. It is an electrophilic addition reaction, and what happens here is your phenol reacts with CHCl3 and NaOH, thereby forming salicylaldehyde. If you form salicylaldehyde, it is Reimer-Tamer. If you form salicylic acid, then it is Kolb's reaction. Got it? Both are said to be electrophilic addition reaction. Got it? Anusha, you can take a look, onto the same Dakana. If you guys want to take a screenshot, please take a screenshot so that it will be easy for you to revise. Yes, hi Surag, hi CVK, hi Soumya. Welcome. Yes. Wonderful, wonderful, wonderful. Talking about timer timer, please take a screenshot as well. This will help you. This will really help you with the concentration in concepts. Crazy. The thing is, I write it in a hurry burry. Okay, that is why it looks like LKG, UKG kind of thing. But I believe that you can understand the concept, right? So, see, once the session is over, I will, I'll just add these notes in the comment section. You can look into the same, right? Yes, salicylic acid, Coles reaction, salicylaldehyde, trimer-timer reaction. Just remember that. Okay. Then, if your phenol reacts with zinc, then it is going to give benzene and zinc oxide. If it reacts with any strong oxidizing agent, then it is going to be para-benzaquinone. This is also very much important. Just understand the concept. What do you mean by quinone? Whenever you have two oxygens attached to an alkyl group, that is called as a quinone group. And yes, this is a quinone because you have two oxygens and one alkyl group attached. Got it? Yes. See, what answer, Akana? What answer? What answer do you want? Next, talking about ethers. This is your IUPAC name of ethers, which is alkoxy. Always remember, whenever you have R dash O dash R dash, you have oxygen as oxygen. This R group as alk and this one as alkane. Ma'am, now I have a doubt. See, if I have CH3 at both the ends of oxygen or C2H5 at the both ends of oxygen. If I have same ends, then I can say methoxy methane, ethoxy ethane. But what if I have different ends like this? In this case, always remember alk, which is smaller in letters, refers to small carbon counted alkyl, and alkane refers to large carbon counted alkyls. Yes, got it. Yes, guys. So, crazy. My name is Premila Kana. Crazy XYZ. My name is Premila. So, remember this. Here, small carbon. The one with smaller carbon is oxy. The one with larger carbon is ethane. So, it is methoxyethane. Remember this. Then, how can I prepare it? I have few methods. I'll let you know. The number one thing is dehydration of alcohol. Just dehydrate your alcohol, right? Hydration means addition, dehydration means removal of water. Just remove some water from alcohol and yes, you will get your ether. But here's the catch. In order to remove water from alcohol, you will heat your alcohol, right? But on heating alcohol, you should ensure that your temperature is just 413 to 423. If the temperature exceeds 423 and reaches 443, then you will not get ether, you will get alkene. Remember this. This is very, very important. See, I am from Kerala, Kana. So my native is from Kerala, a place called as Kozhikode. You must have heard it. Calicut, right? So Calicut is my native. It is where I belong from. Right. Okay, so next we will talk about Williamson synthesis. Williamson synthesis is actually a nucleophilic substitution reaction. What happens here? You take a haloalkane, you make it react with sodium alkoxide, right? Or one haloalkane and one sodium alkoxide. Here, your sodium and halogen reacts to form sodium halide, and the rest, your alkyl groups and oxyalkyl group is going to combine to form your ether. This is basically an SN2 reaction. Remember this. Okay. Yes, Likita. So as I told, basically I am a Mallu. I am from Calicut, a place in Kerala. It is also called as Kozhikode. Okay. But now I am in Tamil Nadu. I must say that as well. All right. So yes, always remember this. In case of Williamson synthesis, you should only take alkyl groups which are primary and secondary. But you should never consider tertiary group. Why? Because if you consider a tertiary group as either alkoxide or as an halide group, a haloalide group, then elimination process will occur, nucleophilic substitution will not occur. So remember this. Okay? Yes. So, hi Sneham. Glad to meet you. Glad to meet you, Kanna. Yes. So coming back to the next concept, which is physical property. Remember, your ethers are all soluble in water. They have very low boiling point. I must have told about the boiling point beforehand in case of alcohol. And talking about ethers, they are least reactive function groups. They are not ready to react. But yes, they react with hydrogen iodide to form a halide group and an alcohol group. So this is all you have to remember. Yes, Kannada. Yes, Kanna. Little. I know a little bit of Kannada. Yes, I was once into Bangalore, Hyderabad, so I know a little bit of Kannada. I know a little bit of Telugu, and I'm actually learning Kannada back for you guys. Okay, so don't you worry. Within few weeks, you will see me very much fluent in Kannada. All right. Yes. So next about halogenation, which is an electrophilic substitution reaction, all you have to do is take your aniline. This is your aniline, by the way. Take your aniline. Take your anisole and make it react with your halo groups. Halo groups. What happens? Your bond break. Your hydrogen gets connected here to form phenol, and you have metal halide group. Right? This is how the reaction occurs. Next, talking about Friedel-Crafts reaction, your anisole reacts with the alkyl group CH3Cl and FeCl3 in order to ensure that it forms alkyl group attached in the ortho or para position. Always remember Friedel-Crafts reaction, ortho para position is a must. Right? So Meghana, next session, I'll let you know the next session, Kana. Don't you worry. So tomorrow we have next session, but timings will be informed beforehand. All right? Yes. So next about acylation. What is mean by acylation? CVK, who's Johnny, sir? I'm not sure, Dakana. Who's Johnny, sir? Which major is his? Alright. So talking about acylation, you take anisole, you make it react with acetyl group, and yes, your acetyl chloride, your acetyl group connects in the ortho or para position. Thereby, Friedel-Crafts acylation also occurs. Okay, Anushka, we will have some more. Okay, Likita, Nane, Nimma, then Hesaru means name, right? So I know a little bit of Kannada, Dakana. Don't you worry, I'm actually learning. I'll ensure that I'm super fluent with Kannada soon. Okay? Yes. I can see a lot of people typing in Malayalam. Yes. Okay, so talking about, thank you so much, Soumya. Thank you so much, Soumya. Thank you so much, Crazy. Coming back to the concept. So, yes, talking about nitration. Whenever you take anisole and nitrate it, you get your nitro group attached in the para or ortho position. Once again, same concept. You are going to brush that same concept. You are going to attach it in ortho or para position. Got it? Yes, Takana. Then we will move ahead with some set of questions from this chapter. Finally, we have come to question set. So just give me some time. I'll give you one beautiful question. Okay. So be ready to answer this question. This was actually asked in NEET exam. It was actually asked in NEET 2024. So yes, let me know your answers in the comment section. Hi, Kriya Jains. Hi, Preetu. Welcome on board. Yes, Kana. Let me know your answers. Okay, Anushka. Sorry, I do not know who he is. That's why. Okay. Yes. Hi, Preetu. Welcome on board. So let me know the answer for this question. Anusha says option D, IKCAGP. IK. Okay, I'll call you Ike. So hi Ike, hi Madilla, hi Aslam, welcome, welcome, welcome. Come on guys, come on. Please answer, please answer. Is it option D? Is it option D? Are you sure? The one which reacts instantaneously, immediately with Lucas reagent is a tertiary group, and yes, option D is the absolute right answer. You guys have nailed it like anything, my dear. Wonderful, wonderful. So I'll give you another question. I'll give you another question. Hmm. Okay, so this is your question. Anisole on cleavage with or on reaction with hydrogen iodide gives. What will it give? What will it give? It was asked in KCET 2020. KCET 2020. Hi Viber, welcome on board. Yes, yes, yes. Let me know your answers. Let me know your answers. Venkataramana, Sihi, Preetu, Vaibhav, Snehal, Saumya, Anushya, Anushka. Everyone, please answer. Please answer the kana. Anusha, please answer. Snehal, okay, very good, very good, very good. So always remember your anisole on reaction with hydrogen iodide will ensure hydrogen replaces metal group and metal group attached with iodine, and thus option C is the absolute right answer. Very good guys. There is no option D, my dear. There is no option D. So obviously option C is the right answer. Very good, very good, very good. So we'll move on with the next set of questions, and this was actually asked in NEET 2018. Okay, this was actually asked in NEET. No, not this question. Mm, ah, I'll give you another question. Okay, I'll give you another question. Okay, what is this reaction called as? What is this reaction called as? What is the name of the reaction given? Come on, everyone. Ma'am, what you say, I like you in Malayalam. Crazy, you can say എനിക്ക് നിന്നെ ഇഷ്ടാണ് എനിക്ക് നിന്നെ ഇഷ്ടാണെന്ന് പറയാം. So എനിക്ക് നിന്നെ ഇഷ്ടാണ്. Okay, I like all you guys. Hi Renu, hi. Let me know the answers in the comment section below. Everyone, please answer, please answer. This is a super duper easy question. Smash the like button as well if you like this session, and of course subscribe to the channel for more such videos, because we have Gopika ma'am, Baswa sir, me myself, Ankita ma'am, Kishore sir, Catherine ma'am lined up to take your classes like nothing before. Yes, so wow, wonderful. Wonderful, guys. Wonderful. I can see a lot of correct answer. Everyone, super. Kudos. So this is actually Williamson synthesis. What happens here? So sodium alkoxide is reacting with your haloalkane, and yes, it gives you desired product. This is Williamson synthesis. Very good, everyone. You guys have knocked our comment section like anything. I'll give you one more question. Let me know the answer for the same. Okay, yes. Reaction of phenol with chloroform in the presence of dilute NaOH finally introduces which functional group? Let me know your answers. In the comment section below. Come on, guys. I trust you, I believe you, and you guys are just beautiful and wonderful with your answers. Anytime, Renu. So happy, Dakana. So let me know your answers in the comment section. Smash it out. Yes, smash it out, Rakana. What will phenol and chloroform give? Thank you, Likita. Thank you so much, dear. C, is it C? Is it C? Is it C? Yes, you guys are absolutely right. It is absolutely, perfectly, and phenomenally option C. Option C is the right answer. Very good, very good, very good, my dear. Okay, so I hope you remember Reimer-Tiemann reaction. If you get salicylaldehyde, you get Reimer-Tiemann reaction. How can you remember it? I'll give you a trick. You must have heard about STR, right? He's an actor called as Simbu. Simbu. Have you heard about him? So remember STR, S is for salicylaldehyde, TR is for Reimer-Tiemann. STR, you remember it, you know the entire reaction. Okay? Yes, yes, yes. Okay, guys, so we will move further. We will move forward. And next we are going to deal with aldehyde ketones and carboxylic acid. This is a very easy chapter. Trust me, it has a lot of naming reaction, which means it has a lot of tricks. I'll let you know the tricks easily so that we will ensure. Thank you, Sihi. Kanna is not just a word, it is an emotion. Thank you so much, Rakana. Yes. So this is a super easy chapter. Trust me, you guys are going to crack this chapter like anything before. Talking about this chapter. First, you have to understand what is aldehyde, what is ketone, what is carboxylic acid, and what are all the other kinds of functional group present. Remember, whenever you have a CHO group, it is called as an aldehyde. Whenever you have a CHO group attached with an alkyl group, it is called as aldehyde. If you have Rajani, just give me some more time, okay? I'll finish this chapter. I'll finish aldehyde within 20-25 minutes. So trust me, it is going to be super worthy. Just wait for a bit of time. Talking about ketone, if you have C double bond O, then it is called ketonic group. And finally, talking about carboxylic acid, if you have COOH group, then it is carboxylic acid. Then about acyl halide, if you have your ketonic group along with the halogen, it is acyl halide. If you have two ketonic group attached by one oxygen, it is acid anhydride. And finally, if you have your ketonic group along with OR dash COO group, okay, COO group, it is ester. And if you have CONH2 group, it is called as amide. Don't you worry, guys. Don't you worry. I'll let you know the entire concepts one by one. Guys, give me just 20 minutes of time, okay? Just give me 20 minutes of time. I'll finish this chapter. Got it? Just give me 20 minutes of time. I'll finish this chapter. Talking about aldehyde. Aldehyde's IUPAC name is alkenyl. If you have AL at last, it is called as aldehyde. If you have ONE at last, it is ketone. And if you have oic acid at last, it is called as carboxylic acid. Yes, Preetu, don't you worry, Kanna. Dekana, this is a very important chapter. As soon as you finish alcohol, if you learn this chapter, it will be super easy for you. That is why, just give me 20 minutes, okay? If you really want to take break, please go have your break and come back. Meanwhile, if you can, if it is possible, sit here so that we will ensure that we finish the concept, okay? Hi, Madiha. Welcome on board. Yes. So, talking about the concept, talking about aldehydes. For sure, sound the strings. Don't you worry. Sihi, who Kanna? Kanna, actually, the thing is, I do not have the access to block people, right? So, as of now, since I'm new to this channel, I do not have the access. That is why I'm unable to block. So, Crazy XYZ, can you please be a bit quiet and listen, the Kanna? Please, can you please be a bit quiet and listen? Yes? Okay. So, yes. Coming back to the concepts. Whoever it is, whoever spamming, please do not, I do not have the access to block them. That is why, please do not do anything, my dear. You are here to study, right? See, just think of your parents. They are putting a lot of effort. To make sure that things are right for you. So stop spamming. Even if it is someone older, stop spamming, because this is an education field. This video is for education purpose, not for any random or ransom messages to be sent. Okay, so please don't spam. Please don't spam. Okay, please be here, because I am counting on you guys, and your parents are also working so much hard to build your life. Remember that, and work a bit, Rakana. Okay, don't spam. Don't spam. Okay, all right, guys. Coming back to the concept. In order to prepare your aldehyde or ketone, we have various other naming reactions involved, right? We have various other naming reactions involved. Okay, so we will talk about the reactions one by one. First reaction is Rosenmund reaction. Okay, what does mean by Rosenmund reaction? My dear, if you take an acyl chloride or even an acyl cyanide group and you make it hydrogenate in the presence of palladium and barium sulfate. That is RCOCl, hydrogenated in the presence of palladium and barium sulfate. Then obviously you are going to get your aldehyde group. This reaction is called as Rosenmund reaction. And in order to remember this Rosenmund reaction, I'll let you know a trick, which is Boss, PET, red rose. Where Boss stands for barium sulfate, you use barium sulfate here. PET stands for palladium, you use palladium here. Red stands for reduction, which means you add hydrogen here, you hydrogenate the molecule. And finally, rose stands for Rosenmund's reaction. So, Boss, PET, red, rose stands for Boss, PET, red, rose stands for Rosenmund reaction. Is that clear? Hi, unknown. Welcome on board. Yes. Next, we will talk about Stephan reaction. And in order to know about Stephan reaction, an easy trick to remember is Stepson is very clever. Stepson is very clever. How can you remember the Stephan reaction, Rakana? Remember that whenever your nitriles or esters react with SnCl2, HCl, and it is hydrolyzed, it will give you your aldehyde group. Here all you have to remember is just the name, the reagents used, and the process followed. Remember, Stepson is very clever. Step is for Stephan. Sun is for SnCl2. Very clever, which means you have a lot of chlorine-based molecule, which is Sn2 and HCl. Got it? Yes. Next. Okay, Amine, what is your problem, Dakana? Ma'am, why do we use quinoline in Rosenmund reaction? Just give me some time. I'll give you some examples so that you can understand the process. Okay? Yes. So coming back to the next concept, which is production of aldehydes from hydrocarbons. You have three methods, but basically you have to remember two, because we have two naming reactions here. One is Ettard reaction and the other one is okay, Bhanuchandra. I mean, I want to tell you guys one thing. Do my face or do my appearance gonna give you 100 or your complete marks in KCET? Is my face going to matter in your KCET marks? No, right? I'm so proud just because I was one who was selected in Indian Air Force as a pilot. The first ever, a lady who got selected as pilot from South India, especially for fighter cadre. I'm proud that I have a Guinness record. I'm proud that I was once selected in 17 government exams. And I'm proud that I am a chemistry faculty for you. That is all that matters. Qualification is all that matters, my dear. Looks does not matter. Trust me, if you get old, looks will vanish. But what you do in life is always going to be there forever. Okay? Yes? So just leave it, my dear Kanna. It is all nonsense. It is all bullshit. Nothing is going to get from here. It is all going to get from here, from your heart. Make it clear, things will go right. Alright, so moving on with the preparation of aldehyde, we have Ettard reaction and Gettermann's Koch reaction. Remember, in case of Ettard, you should know that on You used to say this keyword, etipata cro club, etad reaction na chromyl chloride. Okay, so etad reaction, you use chromyl chloride along it, right? Yes. Okay, thank you, Soumya, Muhammad, everyone. Thank you so much, everyone. Yes. Coming back with Getamin coach reaction. Always remember, whenever your benzene reacts with CO, HCl, AlCl3 and CuCl, you get an aldehyde. Always remember, in case of naming reaction, you should know the name and the reagents used. Okay? Yes. Yes, Kriya. Exactly, my dear everyone. Thank you. Super. Yes. Coming back to the next part, which is preparation of ketones. Even in case of preparation of ketones, you can follow all the methods which was listed before, because from the before method, you can prepare aldehyde as well as ketone. And you should know the physical properties of both aldehyde and ketone. Methanol is a gas, ethanol is actually volatile liquid. Other aldehydes and ketones are said to be liquids or solids. Then, boiling point of aldehyde and ketone, it is always higher than hydrocarbons and ethers. It is lower than alcohols. Talking about, hi Janu, welcome. Thank you everyone. Yes. So talking about the solubility will decrease as the chain length increase. It is not just for aldehydes, ketones. It is for the entire organic compound. So guys, please remember it. Solubility of organic compounds in water decreases whenever the chain length increases. Okay? Yes. Wonderful. Next, finally, lower aldehydes will always have such pungent smell. Lower aldehydes in the sense, the one which has 4 or lesser than 4 carbons, and the one which has higher amount of carbon will have a very fragrant smell. Okay? Yes. So next, talking about the chemical reaction. You have 4 main chemical reaction. One is nucleophilic addition, reduction, oxidation, and reaction due to alpha hydrogen. Talking about nucleophilic addition reaction. Dekana, what happens here is, in aldehyde group, you have a double bonded oxygen, right? And you guys know, if carbon is single bonded, it is sp3. If carbon is double bonded, it is sp2. If carbon is triple bonded, it is sp hybridized, right? So here carbon is sp2 hybridized. You're going to add this nucleophile. So what happens? Carbon can have only 4 bonds. It already has 4 bonds. So it will sacrifice one of its bonds from oxygen in order to add this nucleophile, forming a tetrahedral shape intermediate complex. But the oxygen is so sad, because oxygen needs at least 2 bonds to make sure that it is stabilized, right? Yes. So remember it, just add a hydrogen to make sure that the oxygen is also stabilized. And yes, finally you have a nucleophilic addition process. Here what happens is, your double bonded carbon is converted to single bonded carbon, which means your sp2 hybridized carbon is turned to sp3. Next, you have an intermediate which is tetrahedral in structure, and finally the carbonyl group is attacked by nucleophile and hydrogen. Yes. Very good. Next, talking about reactivity. In case of nucleophilic addition reaction, always remember that aldehydes are more reactive than that of ketone. Right? Next, talking about some more important nucleophilic addition, you can always remember addition of HCl, addition of sodium hydrogenosulfate, and addition of ammonia or any other derivatives of the same can be used in this process. Okay? Yes. Okay. Yes, Dakana. So these are all some of the examples, some of the groups which you can use as in your nucleophilic addition reaction. I'll send you this notes. You can have a new content. Coming back to the next process, which is reduction. Always remember, whenever you reduce your aldehyde, you get primary and secondary alcohol. Whenever you reduce your ketone, you get secondary alcohol. Okay? Yes, Karna, I love you all. I love you all, each and every one of you in this Karnataka channel. Yes? Okay, so talking about reduction. Under reduction, we have two naming reaction. One is Clemmensen and the other one is Wolff-Kishner reaction. Yes? Okay, who da Kanna? What happened? What happened? Who is harassing? What happened? They Kanna, do one thing. Do one thing. Crazy XYZ. Listen, Kanna, I told you beforehand, please don't do this. You're here to study, you're here to focus. If you want to chat and if you want to, speak with them in Instagram, then just go to your Instagram, look into a lot of people who are there in Instagram. You can directly speak with them. Okay? Yes? So guys, please focus into the class. Please focus into the class. Since it is Sunday evening, I do not have the access. I do not have the people who can block you. But I'm telling you, those who are just spamming out here, you're also students. So I want you guys to understand a little bit what concern it is. Study and focus it. Okay? Whoever it is, please don't spam it out, Kana. Got it? Okay, Sneha, I will slow down the Kana. Just focus on the class, Takana. Please don't spam. I want you guys to listen. I trust you guys that you will, you will hear my voice and you will be proper. So please don't spam. Okay? Yes. Okay. Thank you so much. Thank you so much, everyone. Yes. Everyone, those who are all spamming, please don't spam. I'm telling you, please don't spam. Okay? Yes. Very good, Prabhavati. Very good, Rakana. Banuchandra, I want you to stop it right away. Yes, talking about oxidation on oxidizing aldehyde, you get carboxylic acid. And oxidation of aldehyde comes under two tests. One is Tollens test and the other one is Felling's test. So what is Tollens test? You take a Tollens reagent, which is ammoniacal silver nitrate. Yes, so ammoniacal silver nitrate. This reacts with aldehyde to give silver metal. And the trick to remember this is, Amma at night asked you to buy silver. Okay, ba? She was continuously torturing you. Okay, Amma at night tortured you to buy or told you to buy silver tomorrow without fail. So this is your trick. Here Amma stands for ammoniacal, night night stands for nitrate, and silver stands for silver, and thus ammoniacal silver nitrate reacts with aldehyde to form Tollens test or to form silver. Here told stands for Tollens test. Okay? Yes, everyone. Shah, sound the strings. Don't you worry. I'll make a separate video for the same. Okay? I'll make a separate video for the same. Talking about aldehyde, under Felling's test, all you have to remember is, whenever your aldehyde reacts with Felling solution, at first you have to take equal amounts of Felling solution A and B. What is Felling solution A? It is aqueous copper sulfate. Felling solution B, it is sodium potassium tartarate or Rochelle salt. You can call it either ways. So take it as equal half, mix it, add your aldehyde, mix it, you will get a reddish brown precipitate. If you get a reddish brown precipitate, it is aldehyde. If not, it is ketone. In fact, always remember Tollens test and Fleming test is only valid for aldehyde. It is not valid for your ketone group. These are the only tests which can differentiate an aldehyde from a ketone. Yes? Okay. Come on, guys. Next, we are going to deal with aldol condensation. Always remember, the Kanna, leave it aside. Everyone, please leave it aside. Focus on the class. Right? So, talking about aldol condensation, all you have to remember is the aldehyde or the ketone which has alpha hydrogen. It reacts, it condenses, two aldehydes condense to form one molecule. Okay, that condensed form of aldehyde is called as aldol, and condensed form of ketone is called as ketone. And always remember, in case of aldol condensation, you will only use dilute bases, but in case of Cannizzaro reaction, you always use concentrated bases. Also, in case of Cannizzaro reaction, you will take the one which has no alpha hydrogen, say for example your formaldehyde or even your benzaldehyde. Got it? Yes. Okay, next. Guys, we are about to complete aldehyde, ketones and carboxylic acid. Okay, so please be there throughout. Talking about electrophilic substitution reaction, always, whenever you ensure that your aldehyde gets an electrophilic substitution, the substituted part will reach on to its meta position. On electrophilic substitution, the substituted part will reach on to the meta position. Please note it down. Just give me 1 minute, guys. I'll have a sip of water. All right. Okay. Next, preparation of carboxylic acid. How will you prepare a carboxylic acid? From primary alcohol and aldehyde. Whenever you oxidize a primary alcohol and aldehyde with a strong oxidizing agent, then you will get carboxylic acid. If you take alkyl benzene, if you make sure that the alkyl benzene is heated in the presence of an oxidizing agent and the base, then obviously the alkyl group is converted into your carboxylic acid group. Then when you take nitriles and amides, heat it with a little bit of water, you get carboxylic acid. Or in case of Grignard reagent, in the presence of carbon dioxide, this will give you your carboxylic acid under hydrolysis. Yes, unknown. I went to have some water dakana. Yes. Okay. So see, once we finish it, we are on the verge of finishing this part. So once we finish this, we will have a break dakana. Just give me some more time, okay? Some more time. Physical properties of carboxylic acid. Carboxylic acids are colorless in nature. Their odor, if it has 4 or less than 4 carbon atoms, then obviously it has an unpleasant odor. If it has more carbon, then it is odorless. Talking about the physical state, they are liquid if they have very low carbon, and they are solid if they have high carbon. Talking about the solubility, they are water soluble if it is low carbon, and they are water soluble in case of high carbons. Okay, aromatic carboxylic acid is water insoluble. Whenever you have lots and lots of carbon, then it is going to be, yes, then it is going to be absolutely hydrophobic. It does not want to mingle with water. Finally, boiling point, it is much more than aldehyde, ketones and alcohols. Remember this. Right. Next, talking about the chemical properties, your carboxylic acid will react with metal to form electropositive metals. It will react with bases to form salts because it is an acid. So with base, it will form salt. With weak bases, it will form carbonates and hydrogen carbonates. With water, it will form carboxylic anions, COO minus and H plus. With Halogens, it will form chloroforms of acids, and whenever you have more and more of halogens in your acid, it means that the acidity also increases, right? Finally, with esterification, you guys know it. Whenever carboxylic acid reacts with alcohol, you form an ester where OH is gone, R dash is added, and thus we get our carboxylic acid, right? Next, talking about reduction, whenever your carboxylic acid is reduced, it will form primary alcohols in the presence of a strong reducing agent like lithium aluminum hydride or diborate. Then when you talk about halogenation, if you add a halogen with your carboxylic acid in the presence of alpha hydrogen in the place of alpha hydrogen, then it is called as Aldehyde reaction, or the famous HVZ reaction. Is that clear? Is that clear? Yes. With this, our aldehydes, ketones, and carboxylic acid is come to an end. Next, we are going to deal with amines and haloalkanes and haloarenes. Okay. So, yes. Can we continue or shall we have a break? Shall we continue or shall we have a break? Let me know, Dakana. Shall we continue or shall we have a break? Guys, we just have 86 likes. Please smash the like button so that we will reach 100. Okay? Break. We will have break. Yes? Hi, Aradhya, Amrita. Hi, everyone. Yes. Break. Okay, Dakana. Yes. So take your break, take your 5 minutes break. And can you guys be back by 8:35? Will that be possible? So take your break and be back by 8:35. Okay, so be back by 8:35. Yes, please take your break, everyone. Hi, Gaurav. Hi, Renu. Yes, please take your break and be back by 8:35. Meanwhile, if you have any doubts, you can ask me out. Okay? Dekarna, if I give you till 8:40, 8:45, then you will sleep, obviously sleep. So, okay. So please take 5 minutes of break and be back soon, okay? Chaitra, hi Chaitra. Did you ask anything, Dekarna? I'm so sorry that I missed it. Oh, 2075. Hi, Ghost Rider. Take your break, everyone, and be back by 8:35. I'll be here. Okay, Sudeep, just 3 more minutes, Rakana. Just 3 more minutes, okay? Let others come and then we will continue. Crazy, I gave you break by 8:30. It is 8:32 now. Hi, Chaitra. Welcome on board. Welcome on board, Chaitra. Okay, so Vijay, you have a very good score here. So please make sure that you give your best efforts this year. For sure, you will get very good rank. Preetu, we are on break, Kanna. We are on break. Yes, so 2 minutes more, 2 minutes more. Please take your break and come back, guys. So, Mehaboob, obviously, we will look into some questions as well. Don't you worry. So, with aldehyde ketones, I don't think much of question is needed because direct questions will be asked from naming reactions. Direct question will be asked, which I have already, covered. But don't you worry, don't you worry. I'll ensure that I give you some set of good questions to practice. Okay. Likita, I have already informed Akarna. Don't you worry. Explain what crazy? What should I explain? Guys, one more minute. Be ready. Be ready. Vijay, you have high chances of scoring good in KCET and getting onto your ranks, Akarna. So stay focused, stay put, and focus on your KCET. Okay. Okay. Ishita, the questions which I show you are all previous year questions. Okay, or they are all questions which are based on your previous year question. So don't you worry, the questions which I give is probably pretty much similar to what you can get in your exam. You can focus on the questions which I give. It will really help you a lot, Kana. Duration, Preeto, I'm not sure, Kana. Even I'm not sure. Hi, Likita. Hi, Sudeep. Hi, hi, hi. Welcome on board. No, MTG KCET paper is not harder, Kanna. It just takes some time. It will just take some more time to, practice those questions. Okay, so shall we continue? The time is up, time is up, time is up. The break is over. Shall we continue? Preetu, I'm not sure with the timing struck, Kanna. It might differ. It might differ. Okay? Yes. Hi, Sihi. Welcome on board. Hi everyone. Welcome, 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 welcome. Kush Gamer. Okay, I got 237 in PCM. See, always remember your marking scheme is somewhat like this. They will consider your plus 2, which is plus 2 PCM or PCMB mark, which will be taken, 50 percentage of the mark will be taken into consideration. Say, for example, if you have got like 400, they will take, or if you have got 300, they will take 200 plus your mark in KCET, which is 50 percentage. If you have got like example, for example, I am saying if you have got 100, then they are going to take 50. So your total mark is going to be 250. That is how the mark is calculated. Got it? You can score a very good mark, Kush Gamer. All you have to do is focus more on your KCET. Right. So, haloalkanes and haloarenes. Talking about this chapter, this is a very, 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 very important chapter. Why? Because you have inter-chapter link questions here. Also, mainly stick to the syllabus and mainly stick to the trend. This is all you have to do with haloalkanes and haloarenes. So, yes, let me know about one thing. Do you guys really understand the process of uh, nucleophilic substitution, electrophilic substitution, so on and so forth? Do you really understand the concepts? Yes or no? Let me know in the comment section, guys. Sorry for the delay. Yes, shall we start? Shall we start? Yes. With haloalkanes and haloarenes, we are going to smash the chapter like anything. Trust me, this is an inter-chapter link question. You can expect inter-chapter link question from the same. Mainly stick to the syllabus, and yes, make sure that you have a very good eye onto your trends. What are all the trends? What are all the trends which is followed here? Okay. Yes. Got it? Okay, yes, yes, yes. Just give me 1 minute, guys. Just give me 1 minute. I think there is some sort of glitch. Guys, just 5 more likes. 5 more likes for 100. Please do like the session. Please do like the session. Okay, Renu, we will finish it, Rakana. I just need half an hour for haloalkanes, haloarenes, and half an hour for your amines chapter. Okay, so just focus on this. Give tips for inorganic. Inorganic is super duper easy. All you have to know is understand the concept and write your answers. Okay, so basically understand the concept, Kana. That is all you have to do. Okay, so shall we start? Shall we start? Shall we? Alright, so the very first thing which you have to remember is what is haloalkane and haloarene. As you can split it, halo means halogen, alkane means alkyl groups, which is hydrocarbon group. And so, whenever you mix a halogen along with an alkyl group, you get haloalkane. Our hex is the right concept. Haloalkane is mostly sp3 hybridase, whereas haloarene means aromatic, halo means halogen. Whenever halogen is attached with an aromatic compound on aromatic molecule, then it is called as haloarene. Haloalkane is sp3, whereas haloarene is said to be sp2 hybridase. You should remember this. Okay? Yes, I understand, Inspire, but there is no other way. Even exceptions have their own understanding, have their own reason why they have exceptions. So, if you want, I can make a separate video onto the same. If you guys really need it, I will make a separate video for your inorganic chemistry. Right? Talking about the alkyl halide or the RX group. Based on the number of halogen group, you can say it is monohaloalkane, dihaloalkane, trihaloalkane. If it is monohaloalkane, you have just one halogen, di means 2, and tri means 3 halogens. Next, based on hybridization, it is either sp3 or sp2 hybridase. sp3 hybridization in the sense you have your alkylic halide, allylic halide, benzylic halide, and alicyclic halide. If you talk about sp2 hybridization, then obviously you have vinylic halide and aryl halide. I have given you examples so that you can have a refreshment onto the same. Alright? Yes. So talking about the next part, which is what is allylic, what is vinylic, so on and so forth. Almost you should remember that whenever your alpha carbon is sp3 hybridase, which means it is single bonded, but the carbon nearby is sp2 hybridase, it is allylic. But if your alpha carbon is sp2 hybridase, then it is vinylic. Okay? Yes. Then, ma'am, what happens if I remove one hydrogen from the benzylic structure? If you remove one more hydrogen from the benzylic structure, it is called as benzyl. And if you remove all the hydrogen from the benzylic structure, then it is called as benzo structure. So please remember it. Soumya, we will deal with IUPAC Karna. Don't you worry. Okay? Yes. So next, talking about the nomenclature, we have two names which has to be taken. One is common name and the other one is IUPAC. In case of common name, always remember that your alkyl groups comes first, then your halogen group. In your IUPAC, your halogen group comes first, then your alkyl group. Okay, so if you say it as methyl chloride, it is common name. If you say it as chloromethane, it is called as IUPAC. Got it? Yes. So also, considering the molecule and considering the numbering of the molecule, always give priority to double bonds rather than the halogen in itself, the substituent in itself. So in this case, you would get 1 ENE, 3 chloropropane. Yes, 3 chloroprop, 1 ENE. You should remember this. Next, you should remember vicinal and geminal dihalides. Always remember that whenever your alkyl groups has equal number of, each alkyl group has their own halide group, then it is called as vicinal structure. Vicinal structure can be called in common name as ethylene or propylene or butylene chloride. But in case of geminal dial halide, only one alkyl group will have both the halogens. Yes, yes, this is called as geminal structure, and geminal structures are generally named with the common name as ethylidene, propylidene, butylidene, and halogen. Got it? Yes. Wonderful, wonderful, guys. Talking about some structures, I have given you structures. You can look into it. But talking about the main part of the day of haloalkanes and haloarenes chapter, guys, always remember, preparation of haloalkane and haloarene is very much important. Okay? Yes. So from alkane, how can you prepare it from alkane? All you have to do is remove one hydrogen and add one halogen. In the presence of sunlight or in the presence of heat, you can do this, and this process is called as photohalogenation. Got it? Photohalogenation. Next, since you use a free radical halogen here, this process is also called as free radical substitution. Note it down, free radical substitution is very, very, very important. Okay? Mohammed Faizan, your question in itself has the answer, Kana. If you take PCMB instead, it means physics, chemistry, maths, and biology instead. Like PCMB, all 4 subjects. If you have all 4 subjects, then obviously all 4 subjects is going to be considered, right? Yes. Hi Shetty, welcome on board. Yes. So that is how you have to understand. Crazy, just scroll down, rewind it a little bit, you will understand. Okay. Hi Preetu. So next about alkene structure. In case of alkene structure, Marconi curve, our great Marconi curve comes into place. If you have a peroxide, take anti-Marconi curve. If you do not have peroxide, take Marconi curve's rule. Match your hydrogen where there is more or less hydrogens in place based on peroxide. Okay. Then about halogen exchange method, you have 2 important reactions here. One is Finkelstein and the other one is Schwarz. Always remember, in case of Finkelstein reaction, you use, in your haloalkane, you use chlorine or bromine. In your sodium based molecule, you use iodine or bromine. So what happens? Your chlorine has been replaced by bromine, or your bromine has been replaced by iodine, and thus you get your haloalkane and sodium halogen molecule precipitate. But why are you using acetone here as a reagent? My dear, always remember, whenever you use acetone as a reagent, it means that acetone is going to attract all the moisture, keep all the moisture in one place so that the moisture will not disturb the reaction. So always remember, acetone is a must because sodium iodide is highly reactive with moisture. Okay? Hi Sudha, welcome. Hi Yashashwini, welcome on board. Yes. So next about Schwarz reaction. In case of Schwarz reaction, you use a fluoride salt. Muhammad Faizan, no worries, Dakana, no worries. Right? You use a fluoride salt, and all you have to do is take a haloalkane, make it react with fluoride salt, and yes, you will get halofluoride or your alkyl group with the fluorine along with your AgX, which means the halogen gets reacted with Ag group. Okay, is that clear? Hi Chinmay, welcome on board. Coming back to the very important part, which is reduction of alcohol. Always remember, in case of your alcohol, you can either react it with any agents like PCl5, PCl3, any oxidizing agent like PCl5, PCl3, SOCl2, AX, whosoever. You just have to heat a little bit so that your alcohol gets converted to haloalkane. Okay? For sure, crack XYZ, it is easy peasy. Trust me, this is easy peasy. Even NEET or KCET, both are of similar means. You can easily crack it, Dakana. Okay. So any doubts so far? Any doubts so far? Guys, if you have any doubts, please let me know. Please let me know. Yes. Okay. So next we will deal with reaction mechanisms. Trust me, nucleophilic and electrophilic reaction mechanisms are very, 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 very important. Soumya, byproduct is not important, Rakana. Byproduct is not so important. Okay, if it is important, I'll let you know. In some places it is, but I'll inform you. Okay. All right, all right, all right. So note it down, note it down. Now we are here with nucleophilic substitution reaction. So what does mean by nucleophile? Always remember that nucleo means positive, philic means loving. So the molecule which is loving a positive charge is called as nucleophilic. And what happens here? You take your haloalkane or haloarene, you have your nucleophilic molecule. This nucleophilic molecule will attack the leaving group, make the leaving group go away from its place and reach out to your alkyl or positive charge part. This is all you have to do. Got it? Yes. Then always remember your nucleophile is electron rich because it is negative charge. That is why it is attracted towards positive charge and it always forms covalent bond. We have a lot of reactions like SN1, SN2, SN-NGP, neighboring group, SNI, SNI dash, SNAR, so on and so forth. We have n number of enormous nucleophilic substitution, but SN1 and SN2 is just there in our syllabus, so that we will stick to it. This is somewhat out of your syllabus, guys, but if you do not understand this now, trust me, it will be very difficult for you to understand the mechanisms or the processes. So please have an understanding onto it. You don't have to mug up or you don't have to go deep onto the concept, just know it. Alright? Okay, so hi Likita, welcome. So on the strings, once you finish the concept, we will go to questions, Kana. Don't you worry, I have tons of questions lined up. I'll give it to you one by one. Right? So talking about the substrate, what is called as the substrate? The carbocation which is present is called as substrate. It depends, and the reactivity depends on third order, second order and first order, also with the steric hindrance. If you talk about solvent, you have 3 to 4 types of solvents. The main types are polar, which dissolves into positive and negative ones. Non-polar, somewhat like benzene, CCl4, CS4, so on and so forth. Polar protic, which is mostly positively charged, and polar aprotic, which is negatively in charge. Okay? Yes. So talking about nucleophilicity, always remember your nucleophile, it should be very, very strong. It should be highly negative in charge. It should have a very big size and less electronegative. That is when your leaving group is kicked out and your nucleophile adds in. Got it? Yes. Next. Ananya, what is your doubt? So I have given you some orders of nucleophilicity here in the notes. You can have it for reference. Okay, you just don't have to read it a lot. If you are a NEET aspirant, then this will help you out. But for KCET, it is not important. Just go through it, okay? In order to understand the concept, just go through it. All right? Yes. So next, talking about SN1 and SN2 reaction. Always remember, SN1 reaction occurs when a polar protic solvent is used. SN2 reaction occurs when a polar aprotic solvent occurs. Right? So here, the very first step is formation of carbocation. This step is also said to be the slowest, and the formation of carbocation depends on whether you use hydrogen, deuterium, tritium, phenol, or the alkyl groups present in. So I have given you the order. Please have a note of it. Ma'am, second PUC lessons enough to get KCET to get under 1 lakh, ma'am. I am unable to understand what you are asking, Aji. Can you please repeat? Yes. So, and the next step is nucleophilic attack. And in case of SN1, all you have to remember is, your SN1 is done based on a polar protic solvent, and the product of SN1 is going to be partially racemic, which means you will get both original and inverted structures. The temperature needed here is low, and yes, the order or molecularity of SN1 reaction is 1. Right? And the SN1 reaction will not be affected by means of nature of nucleophilicity. It is only affected by means of the leaving group tendency or stability of carbocation. Is that clear? Then we will talk about SN2 reaction. In SN2 reaction, we have a transition state where all the molecules get combined to form one single globule. Then it will break and finally give you the desired product. Okay? Sorry, it will break and it will give you finally desired product. The final product which you get in SN2 reaction is 100% inverse. That is why in some question you can see SN2 products are complete, only original, racemic, partial racemic, or 100% inverted. And your answer should be either 100% inverted or complete inversion or umbrella inversion or Walder inversion. Just know it, guys. Okay, so please hit the like button and subscribe to the channel if you want more such contents. See here, reactivity order of what Rakanna? Which one do you want? Yes. So if you talk about SN1 and SN2 reaction as in whole, your 1 degree haloalkane will always react in SN2 and your 3 degree haloalkane will always react in SN1 reaction. If it is a 2 degree haloalkane, a secondary haloalkane, if you use weak nucleophile, SN1 will occur. If you use strong nucleophile, then SN2 will occur. Okay, remember it. Okay. They Kanna, focus on the class, Kanna. Don't you spam in the comment section, just focus on the class. Right? So always remember your SN1 reaction is directly proportional to rate, stability of carbocation and leaving group tendency, whereas SN2 reaction is directly proportional to rate, inversely proportional to steric hindrance and directly proportional to concentration of nucleophilicity. Talking about elimination reaction. In case of elimination reaction, it is always endothermic, delta H is positive. It always increases entropy because bond breaks and new molecules are formed. So entropy is increased. And finally, the temperature is always high. In case of elimination, you have E1 and E2. E1 reaction is similar to SN1. E2 reaction is similar to SN2. Just how in SN1 you form carbocation, even in E1 you form carbocation and then add the molecule. Right? In case of E2, it is similar to SN2, which means your intermediates are formed. And finally, the product is made. Always remember you have two structures here. In case of E2, one is Zaitsev and the other one is Hoffman. Ma'am, what is Zaitsev and what is Hoffman? Always remember, if you break a bond here, okay, if you break a bond here, just like in case here you had a bromine, right? Now you have broken this bond. Now you do not have that bond, okay? You just have a carbocation formed there. So what happens here is, if your double bond is formed in the same end, either here or here, then that is called as Zaitsev structure. No ma'am, it is not formed in the same side, but it is formed in the opposite direction. The electron is shifted from here to here and then it forms a bond here. In that case, it is called as Hoffman substitution. So always remember, Zaitsev is said to be more stable. Why? Because the electron bond was broken here and another bond was actually taken here. So same side bonding is Zaitsev and same side bonding will ensure that the molecule is stabilized. Whereas Hoffman is not stabilized, it is very, very rare to find the Hoffman process. Okay, which is the slowest step of elimination? The slowest step of elimination, E1 reaction is just like how I told in SN1 reaction. Formation of carbocation is the slower step. Okay, formation of carbocation is the slower step. Ananya, you can write it again. If you really want, you can write it, Kana. If you really want, you can write it. Okay, so yes, if it is a primary haloalkane, it is always going to be SN2 reaction. If it is a secondary haloalkane, you have to see whether the temperature is low or high. If it is high temperature, it is going to be elimination reaction. Low temperature, it is going to be substitution reaction. Then, if it is a weak nucleophile, SN1 strong means SN2, weak base E1, strong base E2. Then, in case of 3 degree, you have to see under low temperature and strong nucleophile, there is no reaction. But low temperature, weak nucleophile, you will have SN1. High temperature, strong base E2 and high temperature, weak base E1. Got it? Got it? So guys, I really want you guys to take a screenshot of these 2 pages. These are very, 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 very important on to your preparation. So please take a note. Please take a note. Yes, everyone, please take a note, Dakana. Please take a note. Yes. Did you? First of all, Ananya, I must congratulate you for getting a very good score. Okay, coming first in your college is a very big thing, my dear. So congratulations for you. But if you really want, if your heart says that you really want to, you really want to do that once again, then obviously you can do it. Right? It depends on just what you think. What you think. If you want to do it, go for it. If not, no. Yes. Okay. Come on, guys. So that's it. That's it. You have learned about all of your reactions. Also remember, in case of aromatic compounds, phenyl carbocation or whatever aromatic compound you prepare, they're all very stable, unstable. And yes, nucleophilic substitution in case of aromatic compounds, haloarenes is said to be very, 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 very less reactive. Okay, well, they will not at all react. The reason is they are aromatic and they do not undergo nucleophilic reaction under normal conditions. So you have to increase your temperature and pressure to a greater extent. That is when your haloarene will react. Got my point? Yes, yes, yes. Superb, guys. Superb, superb. So we'll move on to the next property, which is physical properties. And always remember, low carbon, which is 4 or less than 4 carbon molecules, are gases. High carbon, which is more than 4 molecules, are solid or liquid. Many of them are volatile in nature. Haloalkanes, haloarenes are volatile. They have a very sweet smell, like fruit-like smell. And pure haloalkanes are colorless, but in case of light, they might oxidize, and due to oxidation, they might turn into, if bromine is that, they might turn into brown. If iodine is that, they might turn into violet. If fluorine or chlorine is that, they might turn yellow or even green. Okay, on oxidation, they might change their size. In case of boiling point, always remember that boiling point is directly proportional to van der Waals forces, number of carbon atom, molar mass, dipole moment, and inversely proportional to the number of branching. Yes. Next, talking about the melting point, always remember melting point is directly proportional to symmetry, branching, molar mass, and packing efficiency. Ma'am, I cannot understand these factors, ma'am. Just give me one small trick if you ask so. Then remember, in case of melting point, para-positioned molecules are high melting point, then ortho, finally meta. Whereas in case of boiling point, ortho paves the very first point, then para, finally meta. So howsoever, if you have a match between ortho, para, meta, obviously meta is going to be the last dakana. So remember this. Okay? Yes. Wonderful. So you have some more examples here, some more order here. You can look into it just for your reference. Okay? So I will give you the overall chemical properties here in single page. What you guys have to do is once you you are about to reach to your KCET exam, just look into the single page so that you can ensure that the entire chemical reaction of your and preparation of your haloalkane haloarenes is all set. Okay, so look into it, my dear. Right. Next we will talk about polyhalogen components, which is CHC3, CHBr3, CHI3. They are all trihalides and haloform reactions. Yes, but wait. Let me tell you something about the uses of chloroform, CH3I, and many more. But before going on to it, what is haloform test? Always remember, haloform test is given by metal ketones, 2-degree alcohol, acetaldehyde, ethanol, and geminal structures. Always remember this. Only 5 people out there. Okay. So what are they? Metal ketones, 2-degree alcohols, acetaldehyde, ethanol, geminal structures. So when they all react with halogen in the presence of an alkali like NaOH, KOH, or whatever it is, they will provide haloforms such as chloroform or CH3I, iodoform, so on and so forth. Yes, so we will deal with one by one their uses, so on and so forth. And the first one is chloroform. If you talk about chloroform, it is mainly used in paint removing solvent, propellant in aerosols, metal cleaning. You must have seen in your YouTube short, like whenever you add some liquid onto this metal surface, the color or the paint which is there will tear off itself and come, right? So that is metal cleaning. And finally finishing solvent. You can use it all of these in all of these. Talking about their effects, they have some CNS effect, which is central nervous system effect. They affect the central nervous system. If it is very light, okay, the chloroform which you inhale is very light, you will feel numbness. But if it is very large in count, then it acts as a poison. Even your throat, trachea, bronchitis, everything will be burnt, and you can never, even it will burn your cornea, and you can never see things thereafter. Then, if you talk about chloroform, from chloroform you form a molecule called as freon. If you inhale freon, then your liver is going to be completely unfunctional and you will feel somewhat dizzy. Okay? Yes. All right. Then we talk about iodoform. Iodoform is used as antiseptic and it is used in iodine preparation. Always remember, it has a bad smell, a disinfectant smell. Talking about CCl4, it is used in fridge, it is used as a repellent, and it is actually chlorofluorocarbon. It has only one disadvantage, which is ozone depletion. Alright, so now guys, I'll give you questions, you have to answer me. Okay, be ready for the question. Right. So, yes, this is your first question of the day. This is your first question. Let me know the answer in the comment section below. Come on everyone. Let me know your answers in the comment section. Let me know your answers in the comment section below. This is an example of what? This was asked in 2023 NEET question. Okay, Soumya, we will look into postgene as well. Don't you worry. Okay, we will look into that as well. Don't you worry, Dakanna. But postgene is not asked in your syllabus, right? No, Kanna, postgene is not asked in your syllabus. That is what I told you. Just stick to the syllabus. In syllabus, I can see it is dichloromethane, trichloromethane, tetrachloromethane, iodoform, freons, and DDT. That is all they ask. So just stick to the point. Okay? Do not go outwards. Even if your book has the concept about postgene, it is none of our business. We do not need it. All right. So is this allelic? Very good, my dear. You are all wonderful. You are all very good. You guys have a very good eye because the halogen is connected to this carbon, which means the carbon which you directly connect with halogen is actually alpha carbon. Your alpha carbon is sp3, but the nearby carbon is sp2, which means the structure is an allelic structure. It is an allelic halide. Option C is the absolute right answer. Yes. Anji, PUC2 is not just enough, Dakana. PUC2 is not. You have to ensure that you get a very good score on to your next exams as well. Right. So, okay. So, we'll move on with the next question. We will move on with the next concept. And it is freons. You can see freons. It is used in Schwarz reaction to make the fluorine group. Okay. And if you talk about DDT, it is used as insecticides. And in World War II, it was actually used as a medicine. This is very important. Note it down. In World War II, it was actually used as a medicine. Then DDT had some side effects, so they have stopped it. Okay? Yes. So I'll give you this question. Let me know the answer. Let me know the answers in the comment section below. Look into the question and let me know your answers. Just half an hour more, Pradeep. Just half an hour more. Come on, guys. Come on. Hi, Chandan. Welcome on board. Mehboob was the first one to answer. Option C. Crazy. Focus on the question, my dear. Focus on the question. Kriya, Ramya, option C. Guys, look into the question. It is pent-2-ene. Pent-2-ene. Okay, from 2-bromopentane, it is pent-2-ene. Okay. For ranking below, ranking you are asking. Okay. For ranking below 1 lakh, obviously second PUC is more than enough, Dakana. If you are very well versed in second PUC, then it is more than enough for ranking under 1 lakh. Because ranking under 1 lakh is not a big deal. You have to get ranked below 1000. Okay? Yes. So, Sri Vishnu, ma'am talk few words in Kannada. Chennagide. Yes, guys. I'll come up with few more questions. Ma'am, question not understanding. Dekana. Hi, Ananta Prasanna. Welcome. I'll let you know the question, okay? I'll read it. Please look into it. Product formed in dehydrohalogenation reaction of 2-bromopentane is pent-2-ene. Okay? So, your 2-bromopentane is converted to pent-2-ene. The product formation is based on what rule? Hoffman, Huckel, Zaitsev and Hans rule. Yes, so the correct answer for this question is absolutely option A. Why? Because you have your bromine group in the second position. In that same position, you get your double bond. So what did I say? If your bromine gets disconnected from one position and double bond is formed in the same position, then obviously it is going to be Hoffman. Right? If not, it is going to be Zaitsev. Is it so? Yes or no? Let me know your answers. Is it so? Yes? Yes or no? Guys? So the answer is going to be, is it going to be A or C? Maybe C. Are you sure? C. Always remember, It is actually not SAIDSF. I was trying to manipulate you guys, but still, you guys had a very good answer. So if you remove bromine from one place and add double bond onto the same place, from 2 bromo, you have made that second position as double bond in itself, right? Yes, yes, yes. From 2 bromo, the place where bromine was there, you converted it as double bond, right? So in that case, if same location is converted into double bond, then it is actually SAIDSF. SAIDSF. No, it is not Hoffman. If 2-bromopentane is converted into pent-2-ene, second bromo position converted to double bond, it is SAIDSF. If not, if 2-bromopentane gives you pent-1-ene or pent-3-ene or whatever the answer is, then it is going to be Hoffman. Right? So in this case, it is option C. Guys, you are absolutely right. Option C is the right answer. Very good, everyone. Alright, so this is how you have to understand. SAIDSF is very stable. It is the major product. Whereas Hoffman is the minor product. It is said to be very, very unstable. Got it? Super, guys. Super. Wonderful. So I'll give you one more question. Please look into the question and let me know the answer. This is a pretty much decent question. And this concept, it is like a famous concept for your KCET. You used to get a lot of concept question, and you can expect one question this year from this concept, this naming reaction. So yes, which of the following alkane cannot be made in good yield as per Wood's reaction? Which of the following cannot be a product of Wood's reaction? You have options. Let me know your answers. For sure, Manjunada. Next, we will come up with first PUC. Don't you worry, Kanna. I will make up a video for that. No, crazy. It is actually C. No, crazy. It's actually C. For this question, let me know your answer. Oh, for this question, you are saying it's option A. Okay. Very good, Pradeep. Very good, Pradeep. Shetty. Very good. Steady buddy. Ramya. Everyone. Crazy. XYZ. Very good. Kriya. Superb. So the correct answer for this question is absolutely option A, which is N-heptane, because you guys know in case of Wood's reaction, the end result is always going to have even number of carbon, right? And so option A is the wrong answer, wrong statement, but the right answer. Okay, guys, please like. We are almost 106 likes. Just 4 likes for 110. Please do like. Okay, so guys, please do like. Next question. Let me know the answer for this question, my dear. Let me know the answer for this question. So, identify the product of this reaction. Come on, Dakana. Yes. I'll hide myself so that you can see the question, okay? I'll hide myself so that you can see the question. Please look into the question and let me know the answer. Ramya B, steady buddy, C. Ganavi, C. Fearless frame, C. Sihi, C. Navya, C. Can't see D because D is not there, Kanna. I've given you just 3 options. So the correct answer for this question is, obviously, if you are going to remove bromine and add NH2, then it is going to be It is going to be absolutely in the same place where bromine was there. And yes, option C is the absolute right answer. You guys have nailed it, nailed it, nailed it. Okay, very good, guys. Okay, so, I have answered it. So, just give me 1 minute. Just give me 1 minute. I'll give you one question, okay? I'll give you a statement. I'll give you a statement. Aromatic or haloarenes are more reactive than haloalkanes. Okay, haloarenes are more reactive than haloalkanes. 1 minute, 1 minute, 1 minute. Just give me 1 minute. One minute, guys. 1 minute, 1 minute, 1 minute. Okay, so very good, Prabhavati. Congratulations, congratulations, my dear. In nucleophilic substitution reaction, is this true or false? Nu minus is nucleophilic, my dear. So let me know your answers. Come on, Kana, let me know your answers in the comment section below. Let me know your answers. Let me know your answers. Is this true or false? Look into the question. Let me know the answers. Let me know the answers, Rakana. Okay, crazy. Thank you so much, dear. Thank you so much. False. Why? Why false? Yes, because we know haloarenes are very much unreactive. They are less reactive at normal. They are very much unreactive in case of normal temperature and pressure. In case of nucleophilic substitution reaction, and if you want to compel this molecule to undergo nucleophilic substitution, then you have to ensure that there is very much high temperature and pressure. Okay. So, Ananya, what is meant by Kanna? Kanna is a word which we used to call, which we used to dearly call people. Like how we used to use the word dear, right? So, Kanna is some kind of another word just like that. Okay. So, yes, Kanna, this is the answer. False is exactly right. Because haloarenes are very much less reactive than haloalkanes in case of nucleophilic substitution reaction. Very good. Learn easy. For sure, learn easy. I am actually learning Kannada for you guys. And with this, we have come up with the last chapter of the day, which is amines. So I must talk about this amines for sure. This is a very easy chapter. This is so much easy that you will actually finish this chapter within half an hour. Trust me, half an hour. So talking about the chapter analysis, the total number of questions asked from this part is 2 to 4. Obviously, the question level is going to be very much moderate, easy to moderate. You can get straight questions from this chapter. All right. So we'll look into the concept. First of all, what is amine? You take your ammonia and you remove one hydrogen, add an alkyl group other than that hydrogen group. In that case, the structure form is called as amines. Mostly amines are said to be sp3 hybridized. And always remember. Okay, Vikram. No, Kanna. Kanna is also a name. Yes, Kanna is a name. Few people used to call, have names like Kanna, Krishna. Krishna's other name is Kanna, right? So, but we used to call it out of, have you heard of a person called as Rajinikanth, a superstar? If you see his movie, in most of his movies, all of his dialogue will have this Kanna word. Yes, Kanna is a sweet name which is called just like deer. Okay? For sure, Tabu, don't you worry, you will get very good marks. Okay? Alright. So yes, this is how you make an amine. And always remember, single bonded carbon is sp3 hybridized, double bond is sp2, and triple bond is sp hybridized. Yes! Ma'am, what's tomorrow plan? Don't you worry, we have predictor series coming up tomorrow. So tomorrow we have a chemistry predictor paper session, maths predictor paper session, biology predictor paper, and even physics predictor paper session. Okay? I want every one of you to be there in the session and smash the KCET like anything. Alright? So talking about amine structure, yes, you might not need it, my dear, so that is why I am skipping it. You have primary, secondary, and tertiary amine. Yes, always remember, if you have just one alkyl group, it is primary amine. If you have two alkyl group, it is secondary amine. And if you have three alkyl group, it is tertiary amine. Okay? Yes, Prabhavati, I know AK, the famous AK, right? Ajit Kumar sir. Yes. So talking about amines, ma'am, do question solving class for all chapters. For sure, Tabu, for sure. It is already done, Dakana. Under most expected question series, it is already done. Alright? Yes. So amines are the most biologically active compound. You can see it everywhere in case of your proteins, vitamins, alkaloids, hormones. Everything is made up of amines. And also remember, amines are mostly tetrahedral in structure. Some are trigonal as well. Trigonal and tetrahedral structures are mostly seen. Then talking about their nomenclature, their common name is alkyl amine. Yes. Sure, Prabhavati, I'll look into it. Talking about alkyl amine, which is the nomenclature of your amine group. Always remember, in case of naming your primary amine, first identify the longest chain containing your amine group. Then, in case of carbon counting, you might say that it has 6 carbon, so it is hexane. It has 5 carbon, so pentane. Whatever the count is there in your parent chain. Make sure that you cut E and add the molecule together. That is how you get the IUPAC name of a primary structure. Say for example, if you have hexane, 6 carbon, cut E, then you will get hexanamine. Okay? Give the lowest possible number to amine group. Always remember this. Your amine group, it should get the lowest number, maybe 1, 2, 3 or something like that. Okay? Yes. Coming back to the next part, which is absolutely your secondary and tertiary amine. In case of secondary and tertiary amine, always ensure that the largest alkyl group will form a parent chain, and other groups which is attached to your nitrogen should be their substituents. And finally, you should arrange the substituent alphabetically. If you can look into this example, you can see you have an ethyl group and a methyl group. Look into the smallest one. This will come with your amine. And yes, ethyl methane amine is the right answer. In case of this, you have 2 ethyl group. That is why it is called as ethyl ethanamine. Similarly, you have a propyl group and a methyl group. I have already told you, always the amine group should have smallest carbon count nearby. That is why methanamine, propyl methanamine is its name. Got it? So I have given you lots and lots of elements to practice the Kana. Please practice. I will give you the notes as well. Please practice it to the core. Got it? Yes. So next we will move on with the functional group priority, because in some cases you must have seen that 2 or 3 or 4 functional groups are present sideways. And in that case, always ma'am, KCET below 1000 rank, how many marks I should score? Vikram, it completely depends on how much you have got in your board exam. plus in your KCET Rakana, because 50% of marks is taken from board and 50% is taken from KCET. So I cannot tell you that this amount of mark is enough in KCET. It completely depends on how much you have got in board as well. Right? So please take a screenshot of this. Please take a screenshot of this. Please take a screenshot of this. The one which is on the top, they have higher priority to form functional group. And the one as you go down, 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 they will become your substituents. So please take notes of the same. Dekanna, sure, Aradhya. Sure. So for sure, I'll give you notes by today itself. I wanted to tell you one thing, Dakana. Always remember, the notes which I give you for organic now, it is handpicked. It is especially handpicked. You cannot find this kind of a material outside the market, because out of my 10 years of experience, considering all of those foreign author books, considering all of your NEET exam, JEE exam, so on and so forth, exam books and all, I've prepared the notes. So not just for KCET, you can use it for any other exams. It will be really helpful. All right? Yes. So with this, we will move on with the next part, which is preparation of your alkyl halide. Always remember, in order to prepare the same, in order to prepare your amine, you just have to make them react with ammonia in excess. Ammonia is a nucleophile, that is why it is a nucleophile substitution reaction. The nucleophile is substituted here in place of halogen, and thus finally by ammonolysis, you get primary, secondary and tertiary molecules, okay, or tertiary amines. Then if you talk about nitro compounds, whatever nitro group you have, if you have NO2, if you have nitriles, if you have cyanates, if you have nitroarenes, whatever you have, make them reduce in the presence of strong reducing agent. They will give you amine groups. Strong reducing agent, Aradhya, once the session is over, I will add it in our pin comment. I'll add it in our pin comment. Okay? Yes. So always remember, reduction in the sense you can make use of tin and HCl, iron and HCl, or hydrogen in nickel, palladium, platinum, or even lithium aluminum hydride, sodium, Na, NH2, or whatever molecule you have. All right. Next from amides or Huffman bromamide reaction, as you can see, bromamide. You use bromine and amine here. Yes. So RCONH2, always ensure that you have to remove one carbon here. That is when you get your amine group. Kana, focus, Prabhavati. Come on, Kana, please focus. So whenever you make sure that your amide reacts with benzene and then alkali, you get primary amine. Okay, primary amine is just formed. Remember it. Yes. Okay. Next, talking about Gabriel phthalimide synthesis. Okay, see. Talking about Gabriel phthalimide synthesis, whenever you take a phthalimide and react it with haloalkane in presence of a base on hydrolysis, you get your amine group. Remember, phthalimide is none other than C6H4CO2Nr. Okay, what happens here is your phthalimide is unaffected. Okay, your phthalimide is unaffected. All that happens is you just have to ensure that your alkyl halide is converted into amine group. Your alkyl halide will form amine group. That is why we say that Gabriel phthalimide synthesis is SN2 reaction. It has no intermediate. It is a nucleophilic substitution reaction. There is no bulky amine form. Only simplified amines are formed. Okay. Hi. K-pop. NH-cop. Hi. Welcome on board. Prabhavati, don't you worry, Kana. Just focus. Ganavi, just focus on the class. Kriya, focus on the class, Rakana. Focus on the class. Okay? Yes. So next we will move on with the physical properties, and talking about the physical properties, the one which is lower carbon, they are gases in room temperature, and the one which is higher carbon, they are either solids or liquids. If you talk about their smell, the one with lower carbon, which is 4 carbon or less, they have a strong fish smell, whereas the one with higher carbon, they are less in odor. Talking about their boiling point, they have a boiling point lesser than amines, but greater than that of alkanes. And finally, they are less in dense than water, and their color is mainly colorless, but they oxidize to form yellowish color. Okay? Yes. Next, talking about solubility. Once again, lower amines, they are soluble in water. Higher amines, they are sparingly soluble in water, are hydrophobic in nature. As you know, whenever alkyl chain increases, solubility decreases in case of water. Remember. Next, about basic nature, always remember in case of gas. Okay, 3 degree amine is more basic than 2 degree, 1 degree or amine group in itself. If it is aliphatic amine group, then 1 degree, 2 degree and 3 degree. And finally, in case of aqueous medium, always remember you should follow, for methylamine you should follow 213, and for ethylamine you should follow 231. In amongst all the amines, the strongest amine under aqueous medium is said to be dimethylamine. Please note it down, my dear. This is very important. You might not get this this content outside anywhere. So please take a note. Got it? Yes, Takana. Yes. So next we are going to deal with 1 minute. We are going to deal with chemical reactions. Always remember, whenever amine react with acid, amines is base, acid is acidic, obviously you are going to get ammonium salts, which is diazonium salts or any kind of ammonium salts. If you nitrate the aromatic amines, you will get nitroanilenes. If you react your aromatic amine with nitrous oxide, you will get diazonium salt, like benzene diazonium chloride. Okay. Next, if your amine reacts with acid chlorides, yes. If amines react with acid chlorides, you will get amines. And if your amide is reduced, you will get amides. Okay? Yes. So these are all some reference from NCERT which you might not need. Finally, what do you mean by diazonium salt? Di means 2, azo means nitrogen. If you have 2 nitrogen, then obviously it is called as diazonium salt. Got it? Kanna, I do not have the access to block the Kanna. That is why I'm just leaving you guys to speak. Okay, I do not have the access to block since I'm new to the channel. I have not got access. But yes, I'll get access as soon as possible. Just trust me. Meanwhile, those who are spamming, please don't spam the Kanna. You're here to study, right? So please don't spam. Okay, yes. So talking about diazonium salt. The most important factor which you have to remember is diazonium salts are very much reactive, okay? Due to the presence of substituents and aromatic compound together, diazonium salts are very much reactive. That is why your diazonium salt is always kept in a dilute version. They are always kept in liquid state so that they will ensure that they are not reacting or they are stable at room temperature. Got it? Yes. Okay, thank you. NHKOP, don't you worry, Kana. No need of sorry. You just have to follow the norms. That is all I need. And finally, the uses of diazonium salt. They are uses. 1 minute. Just give me 1 minute, Kana. Yes. Their uses are, number 1, they are used in food, cosmetics, dress or even textile industry. Number 2, they are used in electrophilic substitution. Got it? This is all you have to remember about diazonium salt. Okay. The next thing which you have to understand is Getterman reaction and Sandmeyer reaction. Remember, my dear, if you use CuCl2 along with any halogen based acid, okay, if you use CuCl2 with HCl, CuBr with HBr, CuCN with HCN, in that case your diazonium salt will give you aromatic halogens along with nitrogen. This reaction is called as Sand-Mayer reaction. The same kind of reaction, but if at all you use plain chlorine along with HCl or HBr, then that is called as get-amine reaction. So remember this is very, very important. This differentiation is very important. If you use plain copper, it is going to be get-amine. If you use CuCl2, then it is going to be sand-Mayer. Is that clear? Is that clear? Yes, NHKOP. If you have any doubts, you can place it, Rakana. Place it. If you have any doubts, please let me know. I will answer it. And guys, just 2 more likes for 120. Please smash the like button so that we reach 120. Okay? Yes. So any doubts so far, you can ask me out. Once we finish the doubt, we will look into the question, guys. Any doubts so far? Okay, what do you mean by electrophile and nucleophile? It is very simple, Dakana. Electro means electron, phile means loving, which means the molecule which gets attracted towards negative charge is called as electrophile. Since electrophiles get attracted toward negative charge, electrophiles, they themselves are positive in nature. They are all cations, right? Similarly, if you talk about nucleophile, nucleo means nucleus, which is positive in charge. Phile means loving. And so, nucleophile means nucleus, loving. They try to attract with positive charge. That is why nucleophile, they themselves are negative charge. They can either be anions, or they can have double or triple bonds, or they can also be aromatic compounds. Is that clear? Is that clear? Yes. Kana, we cannot predict how much mark can come from first PUC or second PUC. But I can predict from each chapter how many questions they can ask. Since I have seen all the previous year question, I can let you know that. That is what I am doing with all these mega revisions. Okay. So yes, guys. Is that clear? Any doubts so far? You can ask me out. Any doubts so far? Because next we are going to deal with some super duper questions. And your first question is here. This is from NEET 2024. Aniline does not undergo Friedel-Crafts alkylation. Why aniline cannot be prepared through Gabriel synthesis? Let me know the answers. You have 4 options. Let me know the answers in the comment section. Ganavi, the session is about to be finished. Kana, just maybe 10-15 minutes more. I'll give you questions from all the chapters, right? NHKOP, talking about my introduction. Okay, what shall I say? I was once an Indian Air Force selected candidate. I was once selected into Indian Air Force for the cadre of pilot. Then I left my job there in Indian Air Force. I came out. I started being in EdTech. I hold a Guinness World Record in speech. I also have cleared somewhere around 17 government exams. I have BE in EC, MS in chemistry, and yes, I am doing my PhD in chemistry as well. This is all about me. Yes, so please let me know the answers in the comment section. See, this is not that, since it is a NEET exam, since it is a NEET question, it is not that you just have to focus on to this question because you are a NEET aspirant. See, even for KCET, they ask these kind of question. I just want you guys to focus on this. Ananta, the reason was simple, Dakana. See, my father, he passed away when I was in Indian Air Force, when I was in my training. I do not have a sibling, so I cannot leave my mom alone. That is the main reason why I left my job. But I'm so happy with my present job as well, being a teacher and teaching you guys. Okay? Yes. So I can see a lot of answers. A, D. Come on, guys. Let me know your answers. Thank you, NHKOP. Thank you, Kana. Come on, come on, come on. So, yes. See, aniline does not undergo Friedel-Crafts alkylation. It is absolutely right. Why? Because aniline or the amine group which is present there, that is going to react with your AlCl3 or your FeCl3, whichever you used in Friedel-Crafts alkylation as a catalyst, okay, as a reagent. So that is why aniline will not undergo Friedel-Crafts alkylation. This is absolutely true. Talking about statement number 2, aniline cannot be prepared through Gabriel synthesis. Actually, aniline can be prepared through Gabriel synthesis. Cannot be prepared to Gabriel synthesis. Why? Because in Gabriel synthesis, the end product is absolutely going to be a simple amine group. Okay? Yes. So, my name is Premila Dakana. My name is Premila. Premila. So, yes, statement 1 and statement 2 are true. And so, option A is the absolute right answer. Very good, very good, very good, guys. Option A is the absolute right answer. I'll give you another set of questions, okay? So, yes. This is a true or false kind of a question, okay? This is a true or false kind of a question. And you want to tell me the answer for the same. So, look into the question and let me know whether the statement is true or false. Only primary amines can be obtained from reduction of amides with lithium aluminum hydride. Hi Adna, welcome, welcome, welcome. Only primary amines can be obtained from reduction of amides. Let me know your answers, my dear. Let me know your answers. Sorry. Am I audible now? Am I audible? Sorry, Dakanna. Sorry, I hope I am audible now. Yes. Is it audible now? Is it? Hello. Achacho. Sorry, I hope I'm audible. Yes, super. Thank you so much, guys. So, yes, let me know your answers. The correct answer is if I used half-man bromamide, then I would say no. But if I just reduce my amide by means of any strong reducing agent, then it is going to be absolutely true. Why? Because you guys know primary amide on reduction with a strong reducing agent will give you 1 degree amide, 2 degree amide, 2 degree amide, 3 degree amide, 3 degree amide. Yes, and so yes. It is absolutely false. I'm not using half-man bromamide synthesis, half-man bromamide degradation here. I'm using a strong reducing agent. So yes, the statement is absolutely false. Is that clear? Wonderful, guys. Guys, please like the session because we have reached 122 likes. Just 8 more likes for 130. Please do like. All right? Yes. Wonderful. So, yes, we will look into the next question. And the question goes like this. 1 degree amide can be converted into 1 degree amines by means of what process? Let me know your answers. in the comment section below. Yes, everyone, please, please, please answer it out. See, guys, even if your answers are right or wrong, if your answer is right, then congratulations, you know the answer. If the answer is wrong, then congratulations, because you have learned something new from your mistakes. Okay, so just focus, 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 and let me know your answers. Smash the like button and subscribe to the channel. Come on, guys. Is it absolutely option C? Absolutely option C. Very good, ma'am. You asked the same question previous hand. So obviously it is going to be reduction. Yes, yes, yes. Option C is the absolute right answer. Very good, my dear. I'll give you another question. This is going to be super easy. Okay, this is going to be super duper easy. Let me know the answer for the same. Ethylene ethyl dimethanamine is obtained on reducing what of the following? Which one of the following? Let me know your answers. Let me know your answers in the comment section. Come on, Dakana. Please answer. Please answer. I want every one of you to answer it. I want every one of you to answer. Come on, guys. Come on. This is an easy question. Trust me. You just have to look into the question. You just have to look into the question and the product. Just see how many substituents are there. Just match it out. You get the answer. So Ashish, don't you worry, Kanna. We have Catherine ma'am. She can help you with that. And if you need notes, then you can reach out to me in my Instagram ID, which is neat_Premila_chemistry. Because I have taught both chemistry and physics for NEET aspirants, I can help you with fluid dynamics as well. Okay. So reach out to me through this Instagram ID, my dear. I'll help you out. Option D, very good, very good, very good. Option D is the right answer. Why? Because here you have two methyl group, here you have two methyl group, here you have ethyl group, here you have acetone group, which is absolutely ethyl group, right? So yes, 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 option D is the absolute right answer. And the process is reduction. Here amide is converted into amine, and so the process is reduction. Very good, very good, very good, guys. So I'll give you another question. And yes, let me know your answers. Okay, which is not a byproduct of Hoffman bromamide degradation of acetamide with alcoholic KOH. Which of the following is not a byproduct? It's not at all a byproduct. It cannot be a byproduct. Please let me know your answers. Let me know your answers, Kana. Thank you. Thank you so much, Shetty. Guys, just 5 more likes for 130, okay? So if you haven't liked, please do like the session. Come on, guys. Look into the question and let me know the answer. Few more questions left. I want you guys with full josh. Are you sure? Option B. See, the main process of Hoffman bromamide degradation is to ensure that your amide groups is converted into amine group. Yes, RNH2. Here, if you remove this nitrogen to form cyano group, then obviously it does not make sense, right? You can remove this carbonyl group. Yes, you can remove even water. You can remove even this potassium and bromine. But you cannot remove nitrogen, because if you remove nitrogen, then amine is not formed. And so the correct answer is going to be option B. Option B is the absolute right answer. Very good, very good. B, lock karo, computer G. Option B is the right answer. All right, guys. So we will move on with the next question. Let me know if the statement is true or false. Okay, let me know if the statement is true or false. Gabriel phthalate synthesis can be used for preparing phenyl methanamine. Is this true or false? Is this true or false? Shashati, don't you worry, don't you worry. I've told a lot of tricks here, even in this video, my dear. You can look into it. I'll also come up with PUC 1 video as well, so that you can, you can have a very good look onto it. Yes, yes, yes. Let me know the answers in the comment section below and smash the like button like anything, guys. Smash the like button. Smash the like button. Is this true or false? True or false? Tick tock, tick tock. True or false? True or false? Come on, my dear. Come on. Let me know the answers. This statement is absolutely, absurdly false. Why? Because, see, the product is going to be phenyl methanamine. You know that Gabriel phthalate synthesis will only form simpler amine groups, whereas phenyl group is aromatic and so it will not form phenyl methanamine. The statement is absolutely false. It is absolutely absurd. Okay? Yes. Which questions are more in exam? Physical or organic or numericals? I would say organic, Dakana. Organic is more. Alright. So, next question. Please tell me, pyridine doesn't undergo Friedel-Crafts alkylation and acylation. Is this true or false? This question is about pyridine. So, let me know your answers. This will be your last question for the day. Come on, guys. Please answer. Let me know your answers in the comment section below. What happens, Slayer? Don't you worry. They Kanna, as I tell you every time, as I tell you each and every time, if you know your answer, if your answer is right, then you are absolutely good because you have learned something. Okay, or you are on the right track. If your answer is wrong, then it is also a good sign because you are learning something new. If your answer is wrong and you come to know that yes, the answer is wrong, then you will always remember the concept. So, both the ways it is going to be a win-win situation. Yes, so is it true or false? True? Everyone, I can see a lot of true, Dakarna. I can see a lot of true. Is it true? Aha. Very good. So the statement is absolutely true. Why? Because pyridine is also an amine structure. Amine structures will not fall under Friedel-Crafts alkylation and acylation because they themselves will react with the reagent used, which is AlCl3 or FeCl3. Okay, is that clear? So guys, do you want some more question? Or are you okay with the questions? Let me know in the comment section. Do you want some more questions or are you guys okay with it? For sure, okay. Very good, Soumya. Very good. Do you want some more questions? Yes. Shall we wind up? I have tons of questions here in the PPT, my dear. So you can look into this question, practice these questions because they are all super important in case of conceptual understanding for your KCET exam. Okay, want some more? Okay, so answer this question, my dear. Answer this question. I'll hide myself so that you can see the entire question. Answer this question, Dakana. 1 degree amine reacts with HNO2 to give unstable diazonium salt. 1 degree aromatic amine reacts with HNO3 to give stable diazonium salt above 300 Kelvin. Let me know your answers, Rakana. Soumya, the content wise it is more than enough, Dakana. Content wise it is more than enough. Option C. Are you guys sure? Are you guys sure? Statement 1, statement 2, both are true. Are you guys sure? 1 degree amine react with HNO2 to give unstable diazonium salt. 1 degree aromatic amine react with HNO3 to give stable diazonium salt. My dear, always remember that diazonium salt is always unstable. Right? Diazonium salt is always unstable due to the presence of nitro group. Yes, nitro group and chlorine, which is plus and minus groups together, they are always unstable. That is why you ensure that the diazonium salt is always kept in dilute condition. And so the correct statement for this question is, now let me know the answer. The correct statement for this question is, both are actually false. Okay, because 1 degree amine is not going to give you diazonium salt. Similarly, an aromatic amine will not give you stable diazonium salt, and so both are wrong. Yes, 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 got it, got it. Diazonium salt means it's unstable. It is unstable, it is not stable. Okay, is that clear? Is that clear? Is that clear? Okay, guys, so I'll give you another question. I'll give you another question. Just wait. Okay, so it is going to be a true or false kind of question. This is a very easy question. Okay, you have to let me know. But this concept might be new to you. That is why I am giving you this question. So yes, amine gives carbyl amine test. Is it true or false? Is it true or false? Last question, Preetu. Last question. Just 2-3 questions more left. So maybe I can help you. See, that's it, Takana. Just 2 more questions, okay? 2 more questions and we will wind up the session. So let me know the answer for this question. Let me know the answer for this question, guys. Guys, we have Catherine ma'am. She's very good in physics. So you can look into physics with her class. Is it true or false? Is it true or false? It is absolutely, perfectly and phenomenally true, because carbyl amine test is given by 1 degree primary amine and aniline. So yes, the statement is absolutely true. They have not, see, look into the statement. The statement is amine gives carbyl amine test. It is not that all amines give carbyl amine test. Okay, so look into the question, look into the keywords and then answer it wisely. Got it? It is true. Very good. Wonderful. Super Dakana. Yes. So we will move on with the last question, which is actually a statement based question. Wait a minute. I'll give you somewhat difficult question. Just give me some time, okay? Just give me some time, guys. Just give me some time. So this is your question. Let me know your answers. What is the product here? What is the product? What is the product here, Dakana? Last question. Ganavi, you will have max class. Don't you worry. You will have max class, Dakana. So tomorrow you have max class. You have biology class by 10 o'clock, max class by 2 o'clock, chemistry class by 5 o'clock, and physics class by, I guess it is 7 o'clock. Right? So please make sure that you guys are available. Kana, just 4 more likes for 130 da. Smash the like button. So yes, the answer is absolutely option B. So what exactly happens when lithium aluminum hydrate reacts? Your CN group is going to add some more hydrogen onto it, since it is a strong reducing agent. Then NO2 will ensure that your hydrogen is removed and chlorine is added here. And finally on hydrolysis, this group is completely converted into OH. And so the correct answer for this question is absolutely option B. Okay, so don't you worry. So for guys who cannot see the board, here it is. Please take a look onto it. All right. Yes. So shall I ask you one more last question? Last of the latest of the last. Shall I ask you one more question? Tell me, guys, shall I ask you one more question? So the question goes like this. You have to answer me the most stable. You know, diazonium salts are unstable. But still, among diazonium salt, which one is somewhat stable? The last question. The last question of the day. Okay? Last question, that's it. Yes. Come on, guys. Let me know your answers. And 4 more likes for 130. Please smash the like button. Soumya, option A. Slayer, option D. Slayer slot, option D. Others, please answer. Last question. I want every one of you to answer it right. Okay. Aranya, option D. Crazy, Madhyayo. Is it enough? So yes, the correct answer is going to be absolutely option D, because benzene diazonium salts are somewhat stable than other diazonium salts. Okay, ba? Other diazonium salts are very unstable, but benzene diazonium is somewhat stable. Right? Okay, so with this, we will wind up this session. So we have comfortably and we have wondrously covered our second PUC syllabus. Tomorrow we have an exam predictor series. Starting from morning till night, we will have chemistry, physics, biology and maths covered up. Morning you will have biology, followed by maths, then with chemistry and finally with physics. I want all of you to be there in the session so that with maximal Josh, we will ensure that KCET exam is smashed like anything. Okay, guys, are we gonna smash our KCET exam? Let me know in the comment section. If you are readily available to, smash KCET, get good marks in KCET and rank below 1000. All you have to do is smash the like button. Let me know through the like button. Okay? Yes, Kana. So thank you so much. I'll meet you in the next session, which is tomorrow evening 5 o'clock, predictor series of chemistry. Until then, this is Premila Ma'am signing off. Tata, bye-bye, take care and have a great, good, wondrous night.